Almost forgot to restart the recording. All right, morning everyone. We are moving into week 3 of our training here through the K-12 schools. And this week we are going to be focusing on schedules and alarms. Of course, we'll also talk about the homework for next week at the end of the day. We do have lab scheduled for today. Oh, next slide, Ted. And here is our rough schedule for the day of the order things are going to go in. We may have to shift lab back a little bit, but we'll play it by ear and see how it goes. We are still fighting some technical difficulties, but I'm really hoping by the time lab rolls around that we'll have those resolved. We're waiting on one file from tech support. Gotta love being a prototype, but how it goes. Anyway, we're going to talk about schedules and alarms as our homework discussion. Then we're going to get a little more deeply into schedules, catch our lab into BOP test, and then we will move into our alarms and finish up that discussion. Next slide, 10. All right, just a reminder of who all we are. I'm Robert Nirenberg, he's Ted Walensky, and Larry Chang is hanging out here in the chat as well. So, next slide.
So everybody's already signed in, I assume. So we'll flip on to the next one.
Yep. Yes, Adam, we can see you in the group chat. Just a reminder, again, we learn as a team here, so we all have the opportunity to learn from each other, but just a reminder to please ask questions. As you have them as we're going through, we will, of course, ask right at the end, as we usually do. But if you've got questions, please bring them up. If we go past something that you think is important and you want to add to the conversation, also speak up. Or if you don't understand what we said because we weren't clear to you. Everybody has different backgrounds in this, so let's all learn together. Next one, Ted. All right, meat of the day, schedules and alarms. Well, I suppose we should start by just a short definition of what they are. So a schedule is some sort of pre-generated and agreed upon order of events that we want to have happen with some specific status changes. Most of what we use them for are things like occupancy, related to maybe our HVAC systems or our lighting systems, indoor and outdoor. You know, kind of those, we all keep a schedule, right? We're used to not at work, being at work, and the important thing, of course, getting off of work. You know, that's a schedule, just like anything else. Alarms, on the other hand, are a notification of a problem with our system somewhere. They can be physical and enunciated. They can be completely digital within our control systems. Really depends on how things are set up. And we will go into both of these some more. But first up, it's time for homework. Ted?
That gets us into our homework discussion. So we're going to first cover the schedules, and then after that, we'll cover alarms. And the reason I'm pointing out like that is because what we'd like to do is have people talk about what type of schedules they found and any comments they have on, you know, parts of the building, the areas covered. Do the schedules match the actual use and any other extenuating type of circumstances? Then when we get through with that discussion, we're going to move on to the alarm part of it. We kind of want to keep them separate. So when you talk, let's just first of all just talk about your schedules, and you can talk about your alarms later on. whole point is that we all kind of look at this, we bring up questions, and we can learn from each other on what we see on our systems. So with that, I'm going to open it up for people to start talking a little bit about what they found from their homework when they looked at schedules, what type of areas of the building and what type of equipment was being scheduled and why it was being scheduled. So who wants to step on up and talk first?
I can get us started.
So,
This is Tyler in Des Moines.
hi, Tyler.
What I found, or the way that we do schedules is we have a separate NAE that, like, all the schedules kind of live there, and then use interlocks and BVs, and I don't know, it gets kind of confusing eventually as it goes down the line. And we use this NAE to kind of give direction to all the other buildings, the NAEs at the building, and found that things, we don't have any issues with our schedules that I was able to find, and kind of we use the interlocks to like turn specific banks of equipment on and stage those for morning startups to where we don't try not to hit our peak demand, turn everything on at once. So that's what we use, kind of how we use our schedules. But seems very complex, and it it's something that took me a long time to kind of understand, and I don't know that I've got a full grasp of how it works either. But
Yeah, I was looking at schedules. You said NAE, which is Network Application Engine. So you have a Johnson Control System, correct?
correct, yep.
And the information I grabbed, do you have it on the MUI system, or is it still the older version? Yes,
SMP.
SM.
We're on the new user interface, and the way that we typically work with it though is within the network tree, or the kind of the older style.
Yeah. I have a slide in it. The next slide will show a little bit about that, and I'll be curious to see if it looks any different for yours when I bring that up.
Excellent.
So, good. Well, Robert, you seen some things in the chat? You able to point that out?
Yeah. So we've got some from Antonio stating that most of their schedules align pretty close to what the school are, or the school areas, which makes perfect sense. We do in different buildings, we use different parts differently. So having multiple schedules in those situations makes a lot of sense. They did make a pivot this year and have linked them all to a common calendar in their BAS. And we're going to talk about the interaction of calendars and schedules a little bit. Every system does them a little bit differently, but most do have a calendar plugin type tool. I'm not saying it integrates with other systems, but at least you can plug in some holidays and regular events and things like that. So yeah, that makes a huge quantity of sense, and awesome getting them all on the same calendar. That's a good effort, well worth it.
And it also brings to mind that we're going to want to later on. We'll talk a little bit about schedules and also warm ups and stop and how that ties into it. So,
Yep.
I see Adams talk about temporary schedules for events and how that's really important for them, and also door security.
Yeah.
So, Jeremy, you've got some. Oh, I'm sorry, the screen is flipping on me here. Adam, you've got some tie into your security system, which is really interesting, and having to schedule that. So I don't know if you can open up and talk a little bit about your temporary schedules. You set them up and then they just fade away, or?
Yeah, we well we're still dealing with the TAC iNet Windows 07 that all good. But we do have we had a new wing athletic wing installed or renovated and added a couple of fitness areas, and anyway, that's actually all Siemens right now. And we are able to at least gym wise, the pool area, all those areas are at least able to set temporary schedules that will then um, go back to that. It's go back to that original schedule after that period is over, which is just huge. So we don't have to worry about if we know the events ahead, and even if we're not around, we can just set all that up, and then just peace of mind that we know we shouldn't have any issues with those events. Not that that always is the case, but and then as far as door security, all of that is still for most of the buildings is the TAC iNet. So we've had some major issues where like scheduling is usually not an issue, but we've had some major issues where we lost boards and then doors were down, and obvious, they lock, they fail closed. So, or failed open. I'm sorry. So, luckily there's no issues there, but we've had many times, we're starting with the new system. We're going to break off and get that, the doors through, another, I think it's, Vigilon is the company that's going to be doing the doors. And then, we're going to be using the Distech platform for everything else. So, and that'll slowly start taking over all the schools.
Well, we're going to be following up more with events and versus overrides and impacts on energy and equipment, and also just going in more detail about the differences between those. Rob will be talking about that part, and I'll be talking about the energy part a little bit later on. So.
Yeah, and a lot of what we have talked about focuses more on the HVAC and a little bit on the lighting systems, but absolutely door control is a big part of scheduling. And I'm sure Adam Schultz asked the question for Adam Sini, if you're doing all of this manually right now, which it sounds like you are. And that's one of those things that's used to be very standard in the industry, but now is starting to change. We're starting to see some more integration with outside scheduling software related to, one-off events and things like that, room scheduling, so that we can go into an unoccupied standby type state. But that is a change that is coming, or here in some cases. Jessica.
Yeah, I thought it was pretty straightforward. On our HVAC system, we have morning warm-up schedule that comes on about 2 hours before kids would start arriving at the building, and that warms up above to a warmer set point, and then falls back down to your daytime schedule for set points in the building, and then when school ends, goes to the overnight set point. So I thought it looked pretty straightforward to me on how it's set up.
Good. It's always nice when it's straightforward, right? Easy to understand.
Yeah, definitely.
I do have one question for you, Jessica. Does it seem like that morning warm up is pretty static, always 2 hours, or does it have some variability in it that you saw?
No, it's on a schedule, so it starts at 5 a.m. Morning warm up. Well, at least at one school I was looking at, starts at 5 a.m., runs till 7 a.m., then goes to regular occupancy mode until the end of the school day.
Gotcha. Thank you for
You'd
the
think it
clarification.
would. You'd think it would, because some days it's a lot colder out, but I didn't get that far into it.
Yeah, those type topics will be coming up here shortly. So glad you're thinking about it and brought it up. Thank you.
Yep.
What else we have here? Okay,
Scheduling set to campus usage. Oh, Antonio has a good one here. One of the things they're challenged with is ensuring that all equipment is actually tied to a schedule. A lot of times we assume that equipment is tied to a schedule because, well, of course it is. It just makes sense, right? But the truth is, everybody, all these systems are built by people. People make mistakes. Sometimes they weren't initially designed to be part of a schedule and run independently and now need to be added to that schedule. Or sometimes they just get missed. It happens. Looks like we've got a number of people talking about off schedule events. You know, school schedules are pretty static, right? You know, you've got teachers showing up at X o'clock. You've got students starting to show up an hour after that. Students go home at 3:30, 4 o'clock. Teachers go home at 5. And then maybe we've got PTA groups or rented out to community, all those type of things that we have to deal with separately, right? So that all makes sense that one of the things you're seeing is a lot on those kind of odd event schedules. Makes sense.
now we'll be talking a little bit, I think you already said this, Robert, but about warm-up schedules versus op start. There's some differences between those.
Definitely. I
I
can
see
see.
Gene's. Go ahead.
Nope. I was gonna call it the same, so go for it.
I see Gene's talking about having as many different pieces of equipment on a schedule as possible so they have flexibility and can minimize energy consumption. And that's really important. There's a lot of things you can do with that. But hand in hand with that, it means more eyes on a system to pay attention to those schedules, make sure they're matching the need. Because as you get more schedules out there, it's more difficult to keep track of which one's accurate versus not accurate, because things change. Things change in the school year.
Absolutely true. Adam Schultz says that they have over 18,000 events per year and states it would be a full-time job to do it manually. And
Wow.
you're absolutely right, Adam. And sometimes when there isn't a software that automatically handles those kind of things, and you know, there isn't somebody who is tasked, just like you say, with just doing that. Sometimes that's why things get messed up in systems, that they just get overridden and we end up with, you know, scheduled events on a Saturday when the building is actually empty. And we end up wasting energy. So yeah, you're right. It's depending on the size of the building, the size of the district, it can be a problem of epidemic proportions. And it costs money. It absolutely costs money. So, yeah.
Yeah, at that rate, 18,000, that's on a 200-day schedule, that's 90 a day.
Yep.
It's a lot.
Yeah. That's one of the challenges. So Adam goes on to state that when they discovered this, or his predecessor discovered this, that they pushed it through to develop, it sounds like, some software to deal with the issue. And as we all know, sometimes dealing with legacy systems can be a little bit more challenging. Tyler definitely is dealing with those type of challenges for sure.
Adam also brings up that having a scheduling system allows you to see who's in the building and when. And that's important. It's important to be able to tell that.
Absolutely true. It's
And that's the beauty of controls. You know, we're trying to centralize things and make it easier to do our jobs. Otherwise, we have to go out and look at the equipment item by item, which could be a lot of legwork. So Adam's also using Power BI to look at this from an energy standpoint, comparing it to weather. That's getting sophisticated. Getting pretty good. Adam, we're gonna have to talk to you about possibly signing up for our HPBOP, High Performance Building Operations Professional certification. Does it sound like you're getting into that realm?
I'm interested. I talked to the Maryland Energy Administration to do a case study on taking Energy Star portfolio manager data and importing it into Power BI so you can mess with it a little better and make it more accessible.
Yeah.
I just have 500 tasks. Like right now, I'm even working on an RFP for our solar system, the technical specs.
It's a lot.
It is. I'm fairly new too. I started November 14th, but I've been with the company for almost 10 years.
Remind me, how many buildings do you have again?
We have 25 schools and then other associated buildings. Roughly 15K students. We are not even close to being the biggest in Maryland, though. I believe that's Montgomery County.
Yeah, I mean, that's relatively speaking, that's moderate sized school district.
Oh, we're not the smallest. We're not the largest. We are, I believe, either the second or third largest energy consumer in the state of Maryland, though.
Wow.
Yeah. So, fun fact is, our former procurement manager actually was one of the founding members of ESMEC Energy Trust. So it's a co-op which we purchase our electricity through.
Interesting. Progressive. It's good. It's good. Any other schedules or that people have come up with comments about it? I want to go to the next slide and just show you what schedules might look like on, and this is from my school. So, and then we'll bounce back to the screen and talk about useful alarms. So here's some information I took off of our system just yesterday. And this is just 4 different screenshots. The first one is the schedule for the air handler serving a portion of the wing that I'm in, that my lab is in. So we call it air handling unit number 3. And you can see it's a block schedule. It's coming on at about 6 in the morning and going off at about 9 at night. So it's a pretty simple schedule, and it's a little bit on weekends it runs. And I'm colorblind, so I might say these colors wrong. The blue is when it's in unoccupied, and the yellow is in occupied. Pretty simple, straightforward look at it, and you just go in here and adjust it. And this is on a Metasys system. It's off their new movie system that's all online. You just go to IP address and get on. And down below, you see that it also has a warm-up schedule somehow associated with it. This is something that I'm not sure why it's set up this way. And I'm going to be talking to the people who run the system as to why they have it like this. But there's a separate warm-up schedule listed here, and it's all off. That's what the blue means. Then if we drill down, and this gets into some of the comments about wanting to have as much equipment on schedule as possible to reduce consumption, which is why this is set up this way. We have the VAV box for the lab that I'm in, E115. And you can see the schedule there is much more condensed than the schedule for the air handler as a whole, which is purposeful because we don't want to run the equipment in that room when we're not using the room. The challenge is that, at least in a tech college, we have, when you have an elementary school or high school type or secondary type school set up, you have more of a block of times that rooms are being used. And so it tends to be more similar to the air handling unit. More true for secondary versus, or I mean, for elementary versus high schools. But in a tech college, use of any given room can be all over the board. And it not only is different semester by semester, but even within the semester, we might have different operating needs in the beginning of the semester, the middle of the semester, and at the end of the semester. So this schedule you see here is a challenge because we have in this room, we have 8-week classes, 12-week classes, 16-week classes, and 4-week classes, all overlapping. And this schedule that's in here was set up for the beginning of the semester when there tends to be 16 and 12-week classes in play, and it may or may not include 8-week classes. So this may not even be operating correctly for it. So it gets it back to some of the comments already made about how difficult it is to try to get schedules to match what the actual need is. I just I brought up another screenshot here below that shows a trend of that VAV box, just to show that indeed it's coming on these different time periods that look like they match the schedule. And if you drill down into there, you could see that. And you see, here we have Monday, Tuesday, Wednesday, Thursday, Friday, and then Saturday. This is a full week here. On Sundays, it's off. So it's kind of a odd look on the screen, but it's trending and showing that it's following this very closely. So that's a good thing. And that's one of the things you want to do is make sure you trend information so that the things you think you're putting in, and Robert alluded to this earlier, such as a schedule, actually are being implemented, because they may not be tied, the schedule, to a particular piece of equipment you think it is. So you got to watch for that. Any thoughts or comments on that? I know I want to get a feedback, and I forget who it was with, but I think it was Tyler, about whether this looks kind of like what his schedules are, or the way it looks on his screens.
Yeah, that's how ours looks as well.
Do you know if you have a warm-up setting on yours like this, or is it just the schedule?
We don't have a warm-up setting. Like I say, that's kind of, we've done that manually with interlocks and BVs and such.
Yeah.
We have a similar excuse me, setup. I use the MUI, and I use the older system as well, depending on what I'm doing. If I'm doing a global search, I just like it better in the launcher Johnson Controls Metasys version than I do in the MUI. But it's,
Yeah, some of that's ease, some of it's just convenience, right? You're used to the old stuff. But it is true that some of it's just easier to use in the old system. Do you have something else to add to that, Gene?
no, I was trained to beware of economizers. I know you guys are talking about warm-up schedules and the warm-up option, but it seems to be very closely linked to the economizer action. I believe, if I'm saying that right, that the system looks at, what's happening day after day, week after week, and then schedules a and oh, forgive me, I just mixed that up. Optimal start.
Okay,
That's
yeah.
warm up. It should be, I'm sorry, too
That's
many
all right.
things in my head.
We'll go and describe those later on so everybody knows what we're talking about.
Yeah, so optimal start, to beware of optimal start. Economizers, yeah, they're good. Forgive me, folks. I'm sorry.
Yeah.
But yeah, to beware of the optimal start, because we have at least our youngest schools in Rockingham County, which we have about 21. They're 20 years old. And nothing's been recommissioned, including the outdoor air makeup units, which I'm always skeptical of whether they're operating properly. But those optimal starts, you know, they could fail, and I think they need to be rechecked. And I'm not the qualified person to be able to do that.
Yeah, well, it is something where trending could help you out with that aspect. But yeah, you're right. It's something you have to keep on top of. And historically, economizers, and I was kind of listening to you earlier with this comment, and you're saying they're all kind of linked together. Well, it kind of all goes back to your outside air, return air dampers, and how they're coordinating. And economizers are notoriously bad, especially on rooftop units, for operating correctly. I think the figure was that somewhere around 70% of them aren't operating correctly when they've done some testing on them. And that was a few years back. It may be different today, but I suspect there's probably still issues, which go back to this concept of continuous commissioning that is a good idea to get to, but like with so many things, it's a matter of time and resource that you have available time-wise to do that. So yeah, it's a task, but the more we learn about it, the more we understand about these systems and are able to utilize the things such as trending and getting into our maintenance management systems to check on this, the better off we'll be, because as you get on top of these things, you get them under control, it's easier to maintain them. But once they start going out of control, it can get pretty wild. As an example, METC, the tech college I work for, I think they're finally starting to get a handle on their control system, because years ago, I would look at it and there would be all these overrides in place and just an inordinate amount of them. You shook your head when you looked at it, like, why? Why are they doing all of this? And recently, as recent as 5 years ago, they started cutting back on the overrides. There weren't quite as many. But when I looked at it yesterday, overrides were so minimal. They've really done a good job at minimizing the number of overrides, the number of alarms. 6-7 years ago, when a person started part-time to look at the control systems, they spent months on end looking at alarms. Well, when I looked yesterday, district-wide, which is probably about 14, 15 buildings, they only had 15 alarms on it, which is, I thought, pretty good. But they've been able to put resources towards it, and that resource effort has been in place now for quite a few years to attack it. And it's finally starting to get its impact. And a big reason is that they were able, in the past half year, to dedicate a control company technician to the campuses just to address the controls. And that's been very helpful for them, something that we all don't have resources for. Takes planning. It took a long time for me to get to that point. So,
one more comment. I mean, when we talk about economizers and optimal starts and our dampers and things, we're in North Carolina. We're in the Piedmont area, which is we're not close to the beach or things like that. But when these things don't operate properly, including operating exhaust fans while you're set back at night during the summertime, you can be in the news the next day for mold, and I hate to say that, but I believe this is a safe place.
yeah.
But those are the things that I'm an energy specialist and technician, but I'm trying to protect the building. I want to save energy, but protecting the building is seems to be my my
Yeah.
my first effort.
Yeah. And sometimes that protecting requires wasted energy,
Yes.
because you don't want to be in the news. you don't want to put people at risk, which is the primary concern, right? And you
That's
want
right.
you want your occupants to be comfortable. And mold is something that you really have to be careful with. So, all good points. Any other last comments on schedules before we move on to the alarm discussion for the homework? All right, well, let's go back and we'll talk about the alarm. So who wants to open up and start talking about alarms that they found on their systems and comment about whether it's useful or not?
I'll go. So
All
we've
right.
been having a lot of issues with our network. So I get alarms, communication alarms all the time in RC Studio and WebView. I mean, looking at the same thing, but we know we have issues with the infrastructure. So obviously when it can't poll, it's going to send me an alarm.
When it became what? I'm sorry, what was the last part?
When they can't poll the systems or they don't respond as expected, they obviously send alarms. I also have issues with alarms that the alarm polling period is a little more conservative than the time it takes for things to actually start up. So I get those all the time, and I just kind of have to wait until the equipment's actually ready, and then that alarm clears on its own.
Yeah.
But I definitely need to go through and adjust all the um, alarm polling periods and stuff like that. We have alarms on our chillers that immediately go to an email address and get texted to text and me.
Yeah, and Robert will be talking about the
I don't
alarm.
have an active alarm. I have a programmed alarm, I should say. Yeah.
Oh, okay.
Yeah.
Well, Robert will be talking about alarms from that perspective later on. I don't know if you want to touch base on that right now, Robert.
Yep, might as well. The category that Adam's talking about here is a common one that I'd be very surprised if everybody hasn't run into at least on occasion. Nuisance alarms. Those alarms that just show up every morning or every afternoon and clear themselves without any further action on your part or your team's part, within maybe a short period of time or a little bit longer, depends. But yeah, boy who cried wolf, right? And those are one of the things that make alarms both challenging and unhelpful. So we will be talking more about how maybe we could adjust that.
And I think the prime example of that is, I mentioned earlier about when the part-time person came on for patrols, he spent multiple months clearing out those nuisance alarms because there were well over 1 million of them. But he had to step through each one, make sure it wasn't a valid or not valid item and address if it was, and move on. So it took a lot of time. So you want to avoid that if you can. Any other alarm comments people have?
I found one that was a CO2 alarm that was going off that didn't seem related to the heating in the building, but the alarm was showing that it was out of range and it was like 999, 998. And I thought it's so weird that this is always like as high as it could be without hitting 1,000. And so finally I went up on the roof and disconnected that sensor, and sure enough, then the sensor was just bad. But it kept alarming and it kept on opening the outside air dampers and letting too much cold air in because it thought that there was way too much CO2 in the building. So that did turn out to be useful, but in a way it wasn't, because I didn't look for the alarm first. I was trying to track down why the building's cold, and finally sort of went to the alarms last. So yeah. But yeah, anyway, I have that one.
That's a great example, Jessica. Thank you. And yeah, that happens on many systems. For a long time, very few contractors would put in logic that would protect against sensor failure. It just wasn't an easy thing to do, or sometimes even a possible thing to do with some of the older systems. Newer systems are becoming much, much better about that. They can self-detect when a sensor fails or a signal has gone bad or something like that and go to a default or safe value. But you also bring up a great point. You are trying to deal with a cold building issue, and the alarm panel was not one of the first things that you went to. And I would suspect that's probably because of things like nuisance alarms or improperly set up alarms, again, alarms that aren't helpful. So it's not someplace you go on a regular basis to, help as a troubleshooting tool, which is not your fault at all. That's the fault of the system and the folks who set it up. But hopefully we can get some more information to you to help you tune that in so that it can become a much more useful and regular tool for you to use.
I think it also brings up, that example there was an example of failure, but there's also calibration issues that come into play. And CO2 sensors are one that you really have to pay attention to. CO2 and relative humidity are items that tend to go out of calibration relatively quickly. I don't know what your experience has been, Robert, but that's what I've seen.
Yeah, same. And the other challenge is those sensors that are in places where they can be damaged physically. Room thermostats are one of those notorious ones of, the AV cart hit it. Yep, definitely seen those happen. Seen sensors absolutely scraped off the wall down hallways before. So yeah.
Especially in school environments, they can be just really toyed with. Some people mentioned that in previous weeks here.
Yep.
So Adam Sini talked about the discharge air temperature sensors having alarms quite a bit. Walk-in temp, you mean for walk-in freezers, Adam?
Yeah, both walk-in freezers and refrigerators. Each school has their own. So just to have, like I said, we can't. We're not alerted at home, which is obviously a huge issue. We're working towards that, but yeah, we have every single walk-in at least through the access when we go to the building, and you can see if there's an alarm. But we also rely on, like I said, second and third shift walk in the buildings, and actually we have a log next to each one that they have to verify temperature, and then also notify somebody if the temperature's off.
So that's actually a log right on that piece, on that cooler or freezer, right?
Yes, unfortunately. And then same thing with they walk the boiler rooms, chiller for the high school. We have a lot of geothermal, which is tough, but especially geothermal rooftops, which are a whole nother issue. But yeah, we don't really have the best access to all of it. So once we get to that point, it'll obviously be so much easier for all of us. But yeah, just right now, I'd say just little things like the alarms for classrooms. Like when I can see, discharge air tells me so much. Is the outside air damper working? Is the fan working? Are the cooling or heating actuators working? You can learn so much just from the discharge air sensors. So,
Yeah.
but yeah, no, it's we definitely get a lot, but there's not much we can do until we get into the building. So.
A question for you, how consistent or willing are those second and third shift security people to do a good job at logging that information and letting you
Yeah.
know
Yeah, no, it's not consistent. There's one guy we can definitely rely on, who he actually caught the two boilers that are being demoed at our high school. One of them, the solenoid opened up and it was feeding oil into the boiler and it overfilled and started spilling out everywhere. Luckily, he caught that and I was able to go in and stop it and then clean the mess up. So,
Yeah.
but yeah, no, it's tough. Like I always said, hey, if you need me to like walk with them and show them what they need to look for, because I've been called in for just normal chiller noises because they don't know what it sounds like, and I get a three hour call in, so I'll take it. But I'm just like, yeah, we should probably train these guys.
Yeah, well, and it's better to have them call you in on something and it being false than not
Yes,
call you in and being a problem, right?
100%.
So just as long as it doesn't turn into a nuisance call. Go ahead, Robert.
Yes, yes,
I do have a question, Adam.
yes,
So it sounds like you've got additional alarms during the day, but they're just not being sent out at night. So
yes.
I'm curious, is that a system issue because of a older system that hasn't been set up, or is it an HR related issue?
It's a definitely a system issue, but we have a very difficult IT department as well. With any kind of access, we've been trying to. There is a virtual desktop that we could access, that our one director accesses, but they won't for some reason allow us to do that at home. Just more security, but obviously, if we had that, we would be able to deal with it any time. But or at least say, hey, I might have to come in and check that out because I noticed the temperatures. But yeah, unfortunately, there's nothing set up where this system is the older system sends any sorts of alerts to anyone. So the new Siemens, which is a very minor part of the high school, it's able to send out alarms, and we have trending with that. We don't even have trending with the old iNet. Yeah, it's very bad.
I I've worked with that system. I was a Schneider Electric contractor, a TAC contractor,
Mm-hmm.
for quite a few years, so I'm a little bit familiar with that one. And I don't know what contractor you had who set it up originally, but they definitely did not do a thorough job because that system does have both of those features built in. Because that's one of the things that even older systems has had for a very long time is the ability to send out alarms via email.
Okay.
And email can send it out as text as well. It's just a knowing the right address to send it to for a
Well,
given
I can
function.
tell you that we've had the same contractor since it was installed in '97, which is surprising. They're still around, but the guy actually made comments to me about if we wanted newer systems, he'd have to go back to school. So so this is a main program that I think they're pushing as well, which is kind of crazy to think it's still out. A lot of pneumatics I think they deal with though. But yeah, no, it's very tough. Like I brought like the guy that's been there for 40 years, who's been here since '97. I've brought him out to the high school and he's like, I'm not sure why that's wired the way it is. I'm not sure why you're only getting this amount of voltage here compared to, and then like the guy that does the programming that remotely from Florida, he can't even access certain buildings because the guy that wrote the program before him, he doesn't even understand. So we've had prices to reprogram everything and it's just, but now we're at that point where we're finally getting everything swapped out. So
There you go. And that reiterates one of the challenges or one of the comments that we made, I think, the first week. When you're trying to do energy savings, when you're trying to make the system work more for you than you having to work for it, one of those important things is that the base of the system works correctly, that your sensors are functional and accurate to uh, Jessica's comment about what she was seeing, to having alarms that are being sent out properly, to trend logs that are set up. All of these are basic functions, and if they don't function correctly, or we don't understand how they're functioning, then trying to save energy, trying to make it an effective system can be exceptionally challenging.
100%. Yeah, they went, they went green with all the geos in, like, I think 4 out of the 5 schools, and they all struggle because of the old control systems that we have. So
Yeah, if they're not designed to handle those systems, it could be a problem.
yeah, 100%. And I think I touched on it before, where, like, I saw the voltage. I wasn't even seeing the correct voltage, like, to stroke the valve. So, like, I didn't even know how most of this stuff worked when I got here. It was kind of, and I've only been here 4 years, but now I'm like the pro, because everybody else is retired. So now they, like, rely on me for all of it. So
Yeah. Okay, so I see that Larry in the chat mentioned that they had alarms pop up on motors when they're starting, and that was potentially indication that those motors were failing when the bearings were failing, and so he had to look at ways to address that issue. So alarms can be helpful with looking at equipment that might be close to failure. Notes here. Adam commenting about it's always his fault, according to the users. Yep. Just like with any project for controls.
If I touch it once, I own it.
What was that? Yeah,
If
you
I touch it once, I own it forever.
Yeah.
Then, if it breaks 10 months down the line, it's because what I did 10 months.
Yep. Regardless, if somebody else did something else to it since then, right? Very common with projects where the controls people are typically the last person on site, so they always get blamed for things not working.
I've also seen a lot of issues with companies doing proper punch outs for projects and just kind of trusting vendors, and that doesn't work.
No. Nope, that's not doing a commissioning project, is it? But not every project has commissioning on it, so.
When you're golfing buddies, though, you let things slide.
Yeah. Yeah, it's amazing.
Adam made a great comment as well about how our building operation systems don't always keep up with IT requirements. And I'll fully acknowledge that in a lot of situations, we in facilities don't always get along real well with IT, which is really unfortunate, because we all really do have the same goal, and it's to make a functional building for whoever we're dealing with inside, whoever we consider our direct customers. And it is a challenge. The building controls industry is often right on pace with where IT is, or in this case, really was about 10 years ago. So building controls are historically always behind that 8 ball with IT. They're dragging right along at the tail end of support for the different server operating systems. They're often behind on security requirements, which really gives IT people nightmares. And as we deal with more of these systems, as we're dealing with more of the bad actors out there trying to access our systems and do inappropriate things with them, it really is a very significant challenge from IT's perspective. So yeah, it is a challenge to deal with, and sometimes, even if you're dealing with newer systems, sometimes they still fall behind that version issue. I've dealt with a lot of that over the years, and it's really unfortunate, but it is the way it is, unfortunately. And yes, BAS security in particular is a challenge.
It's something that's becoming more and more important as we go forward.
Absolutely true. Absolutely true.
So the 0 days I've seen start to affect more like these building management systems. I think Snyder actually got hit by one of them, where people were using the cloud service to turn off UPSs, which is crazy when you think about it.
Yeah, it was Schneider through their APC division.
They're not the only one. I mean, Siemens got hit. Like I was a really big part of CISA and stuff like that, so I got all the bulletins and tried to make sure it was none of our gear.
Yep. And they're, I know I'm pointing the finger, or just pointed the finger a lot at the BAS industry, but there's a lot of responsibility there on IT as well for setting up systems in a way that protects those systems from that remote access. So I'm not completely against us in facilities and our suppliers and everything. It's an exceptionally complex set of interactions that we all have to deal with.
And it is unfortunate things are typically reactive, like Adam's pointing out there. And I in defense of the BAS industry, also, I know the big story that people fall back on is the Target hack that happened a dozen or so years ago. And that actually wasn't on the BAS system. It was on the accounting end for the owner and contractor that got hacked, not the BAS system. So, you gotta pay attention to all your systems.
It can be hard to find the vector too after the fact, like especially when they delete all their tracks and encrypt all your server logs. But I think the other big one years ago was Marshall's, when the people were in the parking lot and they found that their point of sale Wi-Fi didn't even have a password on it, and they just started injecting things.
Yeah. Yeah.
Well, that part of the industry is changing. I'm going to slide on down to the pictures I have from our system on alarms, and just go back to this where you look at it. I think somebody else mentioned it earlier today, but you have a way of looking up for alarms. You can see the red icons with the alarm bell in them on a tree diagram for, in this case, a Metasys system that helps guide you to where the alarm is. In this case, it drills on down to a hot water sensor for the primary loop on the boiler. That is an alarm down here. This one here, I came across it yesterday when I was just trying to get some screenshots of alarms, and actually is an issue because in this case, for the hot water reset on the boiler system for the campus I'm on, it's set up incorrectly. Well, it's not incorrectly. It's not set up to optimize what's there now. They have condensing boilers, and when you have a condensing boiler setup, to have a minimum primary loop temperature, hot water temperature of 140 degrees is a little ridiculous. You're not making use of the efficiency, the higher efficiency of those condensing boilers when you do that. So I reached out to operations, and they're looking into it and going to address that. This is on Tuesday this week. It was 74 degrees here at the time this alarm went off, and it had 160 some degrees on the hot water loop. The set point was 140 degrees. So there's multiple problems with what was happening that can be tracked down as you sell this one alarm. So alarms can be really helpful. Hopefully, in this case, they're going to stick the tech on it, and they're going to resolve it and get the settings correct and find out why the system was at such a high temperature when it should have been at 140 degrees. So that will help with energy savings and more comfort too. So the other way to find alarms on the system is by just doing a report. And in this case, I searched on alarms for just the wing of the building that I was in. And these are the ones that came up. Just only 2 of them, which, you know, I told the operations department, I say, hey, this is really good compared to a couple of years ago. You guys have really done a good job in knocking down not only alarms, but overrides and other things. So I gave them some kudos and they were happy about that. Another point worth mentioning is that you do need to provide that positive feedback when possible to encourage people to continue doing what they're doing. Anybody else have some comments on that? Robert, is there any other way to view alarms on a system typically?
Not that I'm familiar with. There's obviously we get notifications from some systems emailing out the alarms, texting the alarms. In the older days, we actually had alarms that would go directly to printers to be printed out, or modems to do an older style dial-up alarm. And I'm not saying that some of those don't still exist, because they absolutely do, but you know, it's not the typical way we do it anymore. Most of the time now we want to see them sent out as a text message or an email alert so that we can jump in the system and see what's going on. It's one of those classic situations of we shouldn't have to go look at the system to find out when it's broken. The system should tell us when it's broken.
Right. Any last comments from everybody on alarms or input to it? Okay. Well, we will jump into our next section, and that's going to be on schedules. And so I'll let Robert take over from here.
Just
You want- Did I move too fast? You want the other slide yet?
no, we can be there. I'm just sending our tech support person is on right now, so give me just 2 shakes.
You want me to start talking about this?
Go for it, man.
All right, so looking at different schedules. In the old days, we did things with these mechanical time clocks or digital time clocks, and you see 2 examples of that here. We did it for lighting, we did it for irrigation, we did it for refrigeration. We did it for our air handling units, all our mechanical equipment, and you know, we don't have a picture of it here, but I just remember always seeing when I go into a boiler room, the gray box, you open it up, it's got a 12 or 24 hour time clock. Well, sometimes it was a 7-day time clock, and it would have all these what you call times on it at the various times you want the equipment to come on, or occupied mode versus unoccupied mode. And it would be set for that particular building as a whole, or it would be set for a particular loop of the building. Just a matter of what they had available, how they had the controls set up. And I'm thinking back to pneumatic systems had a lot of these on them back in the day. And you would often open up one of these time clocks, and the times that set when things come on and off had fallen off and are sitting at the bottom of the what do you call it? Cabinet. They sit at the bottom of the cabinet, and the system's running 24/7. So mechanical time clocks or digital time clocks, both are manual, and they have their flaws. I don't know about you, but I always kind of found the digital ones a little difficult to get around and set. Maybe it just says a little bit more about my age than anything else. But what do you think, Robert?
No, I absolutely agree. I'm a definitely not a Luddite by any means. And the digital ones are challenging. A lot of times they are better about keeping synchronized with actual time versus our old mechanical ones. But they are a challenge to initially set up. And one of the biggest challenges with any of these schedule-based systems outside of our BAS, the old mechanical or digital time clocks like these, is that we don't get feedback in the system. To find out what's going on with it, we have to go out and look at it. So,
Which has its, which it can be really distracting from a standpoint of being efficient, trying to keep your building running optimally. The one benefit I will say that there is to it is if a building operator is not walking all different areas of the building on a regular basis, they don't know what the building sounds like, feels like, smells like when it should be operating correctly, and therefore they won't be able to call out when it's not operating correctly as easily. But I mean, that's probably the primary benefit of when you had to go to those individual areas to find out all that stuff. So
yeah. And there are definitely systems like this that still exist. In most buildings that I've been in, the refrigeration defrost clocks, like the one in the bottom there, are still very present. They may look a little bit different. It may be the more plasticky style of gears. It may be a digital type universal replacement defrost timer. But those, because of the nature of the task that they're performing, tying those into a BAS is really, shall we say, problematic. So we don't often see it done unless it's a system specifically designed to manage refrigeration systems, which I don't know. I'd be curious if anybody has seen those in newer schools or in as part of retrofits or updates on their refrigeration, but I imagine it's probably pretty uncommon. We're more seeing those type of systems in larger refrigeration applications, food manufacturing, grocery stores, large like food courts in malls and places like that. So I'd just be curious if anybody's seen those type of systems in their schools.
I think you just put it in chat if you want to.
Yeah. But one of the, I think, I can't remember if Ted already said this or not, but one of the most traditional things that we did with these external time clocks was outside lighting for parking lots, building lights, things like that, that we wanted just to turn on when sunset hit and turn off when sunrise happened, things like that. And yep, photocells. I'm a big fan of photocells because the truth is sometimes you don't need those lights to turn on until a little bit after sunset, depending on, what the weather's like and all those kind of things. So an opportunity for energy savings. Of course, one of the challenges associated with that is daylight savings time. Sometimes that really messes with those type of systems, as well as time drift, because let's face it, these controllers never had the top end of clocks as far as being able to keep time. Definitely some folks still seeing them. Oh, pool pumps. That's a good one to think of for those schools that have that level of fitness stuff. Good point.
And so we're seeing a lot of the lighting in and coupling with HVAC operations in the notes here. Yeah, typically the lighting ones, you'll open them up and they'll probably be about 8 by 10 inches. You open up and they have a big yellow dial for it.
Yep.
And Intermatic seems to be a company that has a pretty good hold on the market for those things.
It's a fact. They've been around a long time. Everybody trusts them. And the truth is, they're just a clock tied together with a contactor or a pretty solid relay. One or the other, depends on the system. All right, let's go ahead and hit the next slide, Ted.
Okay.
And so, of course, we've got schedules outside the system and we've got schedules inside the system. These two screen captures are off of Niagara systems, Niagara 4 specifically, which is, I imagine, what most of you who are dealing with Niagara are seeing. And it's going to look similar. A lot of companies use this product but call it something else. And a lot of times our schedules inside are related to occupancy. Occasionally we'll see things like lead lag or seasonal changeover. Especially if you're dealing with something like a 2-pipe system, that seasonal changeover is particularly challenging and important to manage. But the kind of scheduling type or the actual schedules themselves, the weekly schedules like we see there on the bottom, are pretty common to look like this anymore. Kind of looking like that Outlook schedule. A lot of drag and drop capability as far as adjusting your times and things like that. So a lot of systems still do that. There are still a couple of older systems where you actually have to physically enter times and it'll list them out, more similar to what we'd expect out of a smart thermostat. That, of course, is only one aspect of the scheduling within our systems. We also have calendars associated with them, as I don't remember who mentioned it earlier, I apologize, but how you tied one calendar to all of your schedules to deal with those exception days, those holidays and things like that.
I think one thing with doing that type of stuff, Robert, is that it makes our lives a lot easier as building operators. But commonly when they fail, it's more catastrophic, more people notice, and it's called, a lot more attention's called to it.
Yep.
So, and people instantly forget about the beauty of having of that all happening in the background before.
That's a fact. That is a fact. So I'd be curious to hear if anybody at their schools is still dealing with a schedule-based seasonal changeover, or schedule-based lead lag. Of course, the other option on lead lag, and what I mean by lead lag is you have two pieces of equipment. Oftentimes we do this with pumps for redundancy purposes. And you have one pump that runs 1 week and maybe it changes over every Monday morning to the second pump. Or if you have something that's the more current way of doing it is that we tend to go off of run times. So I'd be curious, just drop it in the chat if you are seeing either of these.
While waiting for that, I see that Gene comment about the bigger the dial, the worse the adjustments for 7-day clocks. I guess I'm not understanding the comment. I don't know, Gene, if you want to open up and let us know what you're thinking.
Yeah. I think, and I hope I heard the question right. Is that the bigger the dial, that means the more pins you have on the dial.
Yeah.
This past Sunday, I was making my my adjustments. The time is dwindling away as far as daytime is concerned. I mean, nighttime is concerned. So I've had to make an incremental adjustment in the start time of lights and the off time of lights. And I have 6 time clocks at one of the high schools, and this one of the dials is just, it's just so difficult to make that adjustment and then hold the dial in place while unscrewing the little lugs on the end, and and then it's off about an hour. I have to flip through the whole thing to get it's just it's crazy. I don't know why it's not on. I mean, the building is on automation. Why we can't get those 5 or 6 points contactors on automation? I don't know. But anyway, that's what I meant.
Okay, yeah, gotcha. Yeah, it is interesting. It seems like it's just a matter of adding a relay or something like that, and it should be a lot simpler. And it takes time and effort and money. You add a relay, well, a relay's $100, so you got to have wiring and things, so you could have an hour or two wrapped up in all that, and then somebody's got to program it in. So there's another couple hours somebody's got to test it out. So by the time you're done, you have 4 to 5 hours of time wrapped up, plus the cost of the materials, and that's a $600-700 investment. I think that's why a lot of people don't add that extra point, because it does cost money. It used to be when years ago I got involved with a lot of estimating of what it's going to be to put this control on or that control, and you generally would take a rule of thumb of $1,000 a point. And I don't know what that dollar amount is today, but at $1,000 a point, you have to add 1 point. Well, that's more than $600-700 I just mentioned. So it adds up. It adds up quickly. Robert, you have any thoughts on it?
Yeah, the $1,000 a point definitely was the figure that we used for a long time in the industry. That cost, and this is kind of a generalization, so don't hold me to it, because it's not exactly what it is in your area. In the Midwest, those prices have come down significantly. It used to be that our controllers were really expensive, and because of the density of points, really wasn't that good. But that has definitely changed in recent years. So a lot of times, just from a raw hardware standpoint, it's significantly cheaper. But that doesn't necessarily mean that the other associated costs have gone down. Sensors are still expensive. Staffing, the effort to program things, wire things, stuff like that is still problematic, of course. And everything costs money, right?
Another thing that comes to mind for me, Robert, talking about the lead leg, it's always been a question in my mind, and I know there's varying opinions on this, but you have lead leg, so you always have backup. Thought being that if you try to get equal number of hours on both of them, theoretically, does that mean both of them will fail roughly at the same time, which you really don't want? I don't know if anybody has any thoughts on that or not, but
I've definitely
must not be an issue. What's that?
I've definitely heard that debated before. Is why are we equalizing the amount of runtime on these so they both fail at the same time? And there's definitely some truth in that, but it's also one of those situations where if you always focus on one device, particularly with pumps, that oftentimes that unused device will then be very problematic to run when you need it as the backup. If you let a pump sit for a year with fluid in it, a lot of times when you go to start it up, because you need it, it may or may not be cooperative.
Yeah, and seals get old and dried
Cells
up
get
and
old
all
and
that sort of
leak,
stuff.
things get corroded, you know, all those kind of
Well,
things.
I think a simple answer to my daughter question is that it has been happening all these years, so it's not a concern.
Yep, yep. And oftentimes by the time they, especially devices like pumps, um, or the devices that we do often run as lead lag devices, oftentimes by the time we're looking at one or both of those devices failing, it's getting pretty close to the time when they need to be replaced as a system anyway. So it really, again, obviously, like you said, it's been working all these years and we keep doing it. So there's some solidity to the idea. But we are getting some comments on lead lag here in the chat. And it looks like, Jessica, yours is done in the programming. So that's probably a equalized runtime type system if it's not doing it per schedule. Larry's system up there in Fairbanks, they are running one pump on even months, the other on odd months, which is, I've definitely seen that done before. The one challenge that I've seen with that particular item is sometimes the changeover happens when people aren't there during that day. Maybe it's a vacation day or a Sunday or something like that. And so sometimes that changeover doesn't happen smoothly. And a lot of places prefer to have it happen on a day when people are there. First Monday of the month, first Tuesday of the month. I never schedule things for Mondays because that's when everything has gone haywire, right? But anyway, Gene. Running on BAS swap scheduling. Yeah. So combination of things. I was just curious what people were seeing out there with what you've got in hand. Or in auto, as the case may be. Sorry. Poor joke, I know. Alrighty. But let's talk about some important aspects of schedules, shall we? Because there are a bunch of commonalities. It doesn't matter what system you're running them with. So let's hit the next slide, Tim. So every schedule needs to have a handful of things. It almost doesn't matter what kind of schedule we're talking about. We do have to have some sort of date time reference. And again, with modern systems, this is a very minor issue. It's running off of the controller's system clock, which hopefully is synchronized back to your building controller, which often synchronizes to your server, which synchronizes to, the internet time clock. There's a protocol that does that, and hopefully most of you are experiencing that. If you notice a lot of drift within your control systems, as far as the time goes, that would be something to investigate. I know I've definitely dealt with some of the older Andover systems in particular, where as you loaded up their controllers, they lost more and more time because they didn't have a dedicated clock chip. So as they had to do more work, their clock effectively slowed down. And that's kind of a characteristic of older controllers or control systems, excuse me. Newer controllers, newer control systems often have dedicated what are called real-time clock chips that are built into them, and they don't really suffer from that problem anymore. They need to synchronize, every, couple of weeks. Maybe they'll lose a handful of seconds between synchronizations, but that's about it. Older systems, as some of you know, they definitely need a little more TLC, and especially as it relates to daylight savings time. Some systems are good about updating that. Other systems are not at all good at updating that. We of course have most of what we end up seeing and interacting with, I think, is probably our kind of our standard weekly type schedule, Monday through Friday, Saturday and Sunday. And we group those together generically because Monday through Friday, of course, is the work week. And a lot of our systems have tools to set up a schedule on one of those days and copy it just right down the row, you know, Monday through Friday. Sometimes, and often, I should say, the Saturday and Sunday schedules are not part of that generic copy. You have to either program them separately or copy them separately, just so that, because they want you to stop and think about it. And as you all being school folks, a lot of times your Saturdays and Sundays are definitely not going to look anything like your regular school day. At least I hope not. But maybe with the community interactions, it does look more like a full regular day. I won't make assumptions that way. But a lot of these are occupied, unoccupied time sort of schedules, whether they're affecting our HVAC systems or our lighting control systems or something else. We mentioned earlier, irrigation systems are often a schedule-based device for those areas that use them. So our holiday and exception schedules, sometimes this is the same, looks more like a calendar than anything, but it may look a little bit different depending on what systems you have. And these are interruptions or our abnormalities for that regular weekly schedule. Oftentimes the holiday calendar works in conjunction with existing schedules, and can be connected, as I think it was Adam said earlier, on a one holiday or exception calendar can go out to multiple schedules so that the different areas of your building are all synchronized from that aspect. Some systems have different ways of dealing with regular events. So, for example, if you have a PTA meeting every first Wednesday of the month, some systems will have you put those type of events into a holiday or an exception schedule, or they may have some other way of setting that up, or they may have no way of setting it up. It really depends. And a lot of these oddities as far as scheduling for specific abnormal events, like you see a lot more of in schools than a lot of regular office buildings would. A lot of this type of scheduling issues is what's driving that push to let our building automation systems integrate in some manner with our scheduling software. Scheduling software for rooms and things has been around for a very long time, event scheduling software. So the fact that they haven't figured out how to tie them together before fairly recently is unfortunate, but it is how it is. And those types of things are exactly how we end up with overrides and 24/7 schedules and things like that because of these issues. Questions or comments on that? All right, back to you, Ted. I think you're the next slide because we're on to energy, right?
Yeah. Let's see here. Okay, so what type of impact on energy use does scheduling have? Well, there's a lot of different impacts on energy consumption in the buildings. Typically when you think scheduling, we're trying to minimize the number of run hours. And that has a direct impact on energy because if the equipment's running longer, it's going to use more energy. It's just a natural fact, right? Well, why is that? Well, if we're talking about, say, an air handling system, if you're running in occupied mode, you're going to have more hours operation of that fan. And that kind of gets into our quick definition of occupied, unoccupied from an operations standpoint. When you're in occupied mode, the fan in commercial building needs to be on continuously. It's also bringing in some type of mix of outside air and mixing it with return air to the space. So we have fresh air in the building. So you have the energy associated with that fan running continuously. In addition to the heating gains or losses in the building, and in addition to having to condition that outside air to bring in. In unoccupied mode, the typical operation is that the system will go into a state where it's off unless there's a call for conditioning, whether that be heating and or cooling. And in areas like Wisconsin here, in the Midwest, we don't even have, during unoccupied mode, the cooling system doesn't even come on. There's typically not a need for that. So we really minimize our fan energy just by having it in unoccupied mode. Then there's the obvious heat and cooling energy associated with the losses and gains in the different spaces of the building. So if you at night or in unoccupied mode, you're going to have a different set point. In the winter heating season, it's going to be much lower than your occupied set point. So because you have a lower temperature, you're going to have less heat loss to the outside. And vice versa in the cooling season, during the unoccupied mode, you're going to have a higher set point temperature and or not even let the system come on at all, so that you're not going to have anywhere near the heat gains into the space that need to be removed and or don't even remove them at all. I've often been hit with this comment when I go through that description that, well, but you gotta use all the energy when you turn the system back on to get the system back up and running. So you're not saving any energy. And that statement simply is false, because anytime you're at a different space temperature or a set point and maintaining that temperature, you're going to be at a different heat loss or gain to that space. And so in occupied mode, you're at the point, let's just call it 72 degrees, that you want people to be comfortable in. During the heating season, if in unoccupied mode, you set it back to say 65, 60, or 55 degrees, depending upon your systems, you're going to have a much lower loss to the outside because of that lower temperature in the space. So you're saving the energy that you would have lost otherwise. So you always save energy when you have your space conditions at either lower for the winter or higher for the summer during unoccupied modes, or occupied modes for that matter. So just keep that in mind. Now, it is true that, let's use a winter example, when you want to bring the building back up to occupied mode and you're going from, say, a 60-degree space condition up to a 70-degree space condition for occupied mode, you then have to warm up all that volume of air from 60 to 70, plus you have to warm up the different objects in the space that have cooled down overnight. So you do have to do that. Your system's going to run at a higher load for a while to make that up, but that is not anywhere near equivalent to the amount of heat that would have been lost to the outside had you just maintained everything at 70 degrees. So you always save energy when you have setbacks, or in case of cooling setups. So that's something to think about and consider. And in addition, during unoccupied mode, you're not bringing in all this outside air. So if you're able to schedule things to be in unoccupied mode, then you're going to not be bringing outside air, which you then don't have to condition and you're saving energy. So there's this huge impact that you can have by using unoccupied versus occupied mode here and keeping your schedules as tight as possible. The non-energy related part of that happens to be that if you're always operating, the equipment's always operating, you're going to have more wear and tear on equipment. So there's going to be more maintenance involved and you're going to have to replace that equipment quicker. So there's this other impact that we need to be aware of and deal with. So those are types of energy impacts that you're going to see. Now, having said that, what type of energy might we see as savings that we might see as a result of reducing our occupied time? Well, on a 10,000 CFM fan system, roughly a 10 horsepower fan, and you're going to see somewhere around 350 therms a year and 2,700 kilowatt hours a year savings, which could be about a $600 per year reduction in cost, energy costs for that particular air handler, just by reducing 1 hour a weekday. So it's 5 hours a week over the course of a year. So there's these very tangible savings that you can get. Then, if you look at reducing the outside air for the same system, reducing from, say, a 30% by 10% on your system, you can add another $750 a year. So it's important to look at your scheduling to try to knock down your energy cost. So I see Adam's put some things into the chat here. 7 to 3 degrees. So
7 o'clock to 3 o'clock was the our old set points.
Yeah, so you do have that issue with bringing that thermal mass of the building up. And you have to be aware of that. A lot of the optimal start stops will have parameters in them that allow you to adjust for the mass of the building, so it will account for that in warming it up. That's where somebody had mentioned that they don't trust the optimal starts to bring things up in time. And
we have issues with people propping doors. Some of the envelopes aren't the best, so there's a bunch of factors hitting us. I'm actually going to look into some analytical software that one of our controls companies produces that looks at your occupied set points, how long it takes to get to them, whether or not you would be better off changing parameters and stuff like that. I'm going to apply that to one of our high EUI sites and see how it works out.
Yeah, I think that today we're seeing a lot of those tools really progressing in their ability to account for that.
There's also the huge push for AI, and it's one of my pet peeves right now, because I don't feel that AI is more than a glorified switch statement that's based off of data that it has access to.
Data that has what?
Data that it's had access to. So AI is basically like a learning model that's raking the internet for information right now, and then basing things off what it's saying. The problem is that there's a lot of false information on there.
Yeah, garbage in, garbage out, right?
Yeah. So I'm a little apprehensive, and I find that a lot of people oversell AI.
Yeah.
But, I mean, everything else.
You really have to, like with anything, pay attention to it, watch it. It's just like with our control systems and the ability for them to really help us out with maintaining comfortable spaces and saving energy in our buildings. It has a cost. We have to pay attention to it. You just don't put a control system in and let it run. And I think we're going to do that with AI also, that we have to pay attention to the results from AI to make sure they're logical.
Well, you always
much
have to look at data in context. And I feel that a lot of people tend to just look at raw data instead of other variables that are affecting it, causes information to be jaded.
Yeah. And it just takes eyes to be on it, to pay attention to it. And you have to have a feel for your abilities to make sure it makes sense. So. Yeah, all right. So that's, any other thoughts on energy use based on schedules? Anybody have some other examples? All right, well, then I'm going to go on to the next slide, which is going to take us to overrides impact on schedules. And this is going to be tossed back out to you for your input on what you think and what you've seen for overrides and what they've done to your schedules over time. So anybody want to step on in and provide an example of what you've seen on your system? If not, I'll start talking about an example I've seen. Well, the example that is probably kind of a little thorn in my side, but I've seen is that in VAV systems, someone has gone in and you get a complaint in a space. Too cold, too hot, too noisy. An operator goes in and overrides that particular VAV box to be higher airflow to try to make the people more comfortable in the space. And I've seen where this has happened on VAV systems on enough of the VAV boxes that effectively the air handler, which has a variable speed drive on it, is now operating at or close to 100% all the time. And of course, the VFD is on there to vary the fan airflow so that you can save energy and better meet the comforts of the people in the space. When you have too high of an airflow in a space on a consistent basis, you're going to have too cold of spaces during the summer months when you need the cooling. You potentially, because it's such a high airflow, you're not going to have the reduction of temperature of the supply air to the point of pulling moisture out of the air. And you're going to run into issues, as mentioned earlier today, with potential for moist spaces creating a moldy atmosphere. And you don't want that. So there's all these things that overrides come into play and can impact your energy consumption, can make the spaces uncomfortable, make them cold. If you have areas of your building that are served by VAVs that are lightly loaded, not a lot of people in them, then they're going to get cold. But you might still have people in there. Prime example I've seen is where in a school, you have VAV system handling a couple of classrooms, couple of labs, and administrative office. Well, you go into the summer months, these overrides are still in place, and it's causing a lot of airflow, cold air going into this administrative area where in the summer, they're bringing in heavy sweaters and trying to dress really warm to counteract the cold airflow coming into your space because of these overrides. So it's an issue. It's a big issue. Adam's commenting about demand response, scheduling demand response into the system. And I don't know, Adam, you want to open up as to why it defeats the point of a VFD demand response? Is that what you're saying?
No, it's the comment you're talking about, the VFD running at 100%.
Oh, okay.
Yeah.
All right.
So I mean, a VFD is typically, you want that to be able to have thresholds of output or whatever. That's why we would-
Yeah.
So if you're always running it at 100%, you could just buy a regular drive that doesn't
Yeah.
have the ability to alternate the output. So you just overpaid, basically. But no,
Yeah, why
I'm
would
saying
you
like,
want-
I get an advance notice for DR events. And I mean, I'll put the schedules in sometimes ahead of time. So that was more, there's two separate topics, sorry.
Okay. Another example of something to think about for scheduling is that demand response. So is your utility the one that's calling for the,
No, it's
Um,
NLX. So I imagine they're probably owned by Delmarva Power somewhere down the line. But basically, they take 25% of the incentive we get when it's that type of demand response event.
okay.
One when they're doing capacity tags and all that. But we haven't talked about any of this, so I don't want to throw a bunch of things out that some people might not be familiar with without discussing it.
So that's a third party entity doing that. Then
It's a third party. We don't pay anything. They just take, the utility companies will typically incentivize customers through programs if they reduce their load on the grid during certain hours. And that's one of our partners that we do this.
yeah, and the nice thing about having that third party do it for you is then it frees
You
up
got
time.
you got eyes on the future all the time. So it's not
Yeah.
something I have to keep looking at, anticipated demand based on historical data or what you have. They're looking at the weather. They have all kinds of tie-ins. They actually get our direct usage. I'm sitting here verifying all the meters right now.
So plenty of advantage of that. And that's an example where having a third party can be very helpful to give you the ability to take advantage of a program and make some money off of it. Whereas if they weren't there to do it for you, you wouldn't be able to take advantage of it because you don't have the time to do it. It kind of reminds me of I've been looking at utility consumption and rates since the mid 80s. And at the time back then, there was natural gas being deregulated. And so you could always go to a third party to get transportation gas. And that would typically save you money. And the savings back then were probably 5 to 10% of your gas costs. So it was a pretty significant savings for larger entities. But somebody in-house had to have the ability to watch that, think about it, and take the risk of projecting out when and what type of costs you want to have. And the same thing applies, I'm imagining, with NXL, but I think today those type of things, they're handling all of it for you. So it's not exactly all hands off on your part, but a lot less onerous and easy to do as a result. So how about some other examples people have of overrides that they've seen and how that impacts their system? Anybody?
Go
ahead, Jessica.
I'm just thinking of one where we had lead lag on circulating pumps, and one pump, the motor blew up, so we put the schedule in override, so the other pump is on lead all the time. But then after we fixed the pump, no one remembered to go back and remove the override and go back to lead lag. So then the other pump is getting way more use than it should. So then it kind of defeats the purpose.
Yeah. That can happen. And that's one of the things. We're human, right? There has to be a good method. And the way to handle something like that, I would think, would be when if you have a computerized maintenance management system, when that call for that pump to be overhauled came in, there should have been a procedure inside that CMMS to, when it came back online, to go and release that override.
And maybe to confirm operation too through the BAS. That would make sense.
Robert's giving you a thumbs up on that. Yeah, it's definitely something that we need to do more of. And we're all guilty of that. We are always trying to get on to our next thing, and it creates issues that way. Has anybody seen overrides where somebody just temporarily overrides a schedule or overrides a set point or on-off status or something, and
Yeah.
then it becomes life? Go ahead, Gene.
Yeah. I get especially during the cooling season. Some of our well, we have three HVAC techs for our three parts of our county, and if there's a comfort issue, without telling me, I'm usually the point. I should be the point person. They'll go ahead and override the occupancy status to occupied continuously, and if they're super ambitious, they'll do that with the occupied point command, and they'll also do that with the supply fan command. And yeah, with I'm sorry, I'm one of those folks that for the alarm part of this session, I have 1,000+ alarms that I I find too daunting to deal with. It may be different after this this class, but I can't find that as far as the alarms are concerned, and I find it when I go walk through the buildings during unoccupied times.
Ah,
I come
yeah,
across a room, I have my computer with me, it's running, it's cooling. If the fan was on, I wouldn't be so upset. But when it's cooling on a Saturday afternoon or a Sunday afternoon, I really get upset. And I
yeah.
know I lose savings because how long
Yep.
has it been running like that? You know, it just makes me upset. So yeah, that's
Yeah,
the
that's
impact on the schedule.
yeah, and that's the problem with overrides on occupancy or set points is that you have to remember to go back and release it. And
Yeah.
so often it's not done because we are human. We get dragged on to the next thing and we forget to do it. And that's
I'm sorry. The really great thing that I've seen with overrides, a heaven sent is the timed override.
yeah,
That's it's this week it may be hot. I mean, we're in the shoulder season now. Next week we're gonna be a little cooler. So if the person's hot, why don't you just maybe override the occupied cooling set point a little lower temporarily till the end of the week, and then it'll be cooler next week. Things will be better. Or go touch the unit and see if it's operating efficiently. Do whatever you have to do. But anyway, that's
yeah.
overrides.
Another good idea for that, Gene, for timed override is when you're entering a period of below zero, 10, 20 below zero, where you need to make sure the systems are running overnight just so you don't lose them. That's another good example where you could put in that timed override. So,
Yes, yes.
whereas in Jessica's case, she wouldn't want to put a timed override in on having to repair that pump because you never know how long it's actually going to take. And you don't want that override to release before the project's done. So you got to pay attention to when you want to use that.
Well, you can let them know. You can give them, hey, look, heads up. You only have 3 days to get this pump working before
That's
it comes on.
yeah, yeah. And you got trust but verify that they get that done, right? So you don't let it release when they're not done yet.
Yeah, that sounds like that would be dangerous because like
Yeah.
shipping delays or someone just called out sick that day. We don't have a very big crew, so one person out sick can, just throws our whole planned work off for the week. So yeah, that would be, I mean, I'd love to say that. You have 3 days to fix it, go do it.
Well, what you could do is tell them they have 3 days to fix it, but put the override in there for an extended period of time that's way beyond when it will be done, so that you don't have to worry about it.
Yeah, there you go.
We've
So,
been having some conversations with our district or with our controls companies that we work with regarding, we have dashboards for each one of our controls companies that kind of tell us, chill water supply, hot water supply, how many flags are out. And We've recently been talking to them about adding another column that would just light up to let us know if there's anything locked or overridden at that particular facility. And then if we are to click on it, it would tell us, what exact areas or what equipment is locked and what's locked, so that we can figure out, oh yeah, I have that locked for a reason. I'm waiting on a part, or, someone just, like you guys were saying, sometimes we have other people that are not us that go in and lock stuff, and then they get busy and they forget it. And we find out 3 weeks later that it's been locked the whole time. And so just having that conversation with controls companies, and now hearing that it is in fact an option, and something that, we're just in the beginning stages of having those conversations, but kind of excited about having that as a possibility.
Well, and Melissa, one thing I'm curious about is, are people putting in notes to tell you why things are overridden or locked out?
Sometimes,
Mhm.
and so we've had to go into our programming too, and just give people read-only rights to force them to contact. That's fixed a lot of the problem, where they have to contact either myself or one of my team members in order to get that equipment locked. The problem we run into is that sometimes we have people on site that'll put things in hand, and we don't know about that. And they don't do it on purpose. They're busy fixing something, they put it in hand, and they end up going down a rabbit hole trying to figure out where the problem is. They finally get it fixed, and they forget to go back and, oh yeah, I need to take that air handler out of hand, and I totally forgot.
Yeah.
So it's not intentional, but it happens. So, but this being able to do this on our dashboard would tell us, hey, air handler 3 is in hand. You may want to
Yeah.
know that. So we'll see where that goes.
Yeah, if you have some feedback mechanism for telling you that. We don't always have the feedback mechanism to tell us that information. And that's where trending and things might be helpful. Or the good old walk the building, look at it, like Gene was mentioning, overnight. He's walking the building and checking things around weekends. But that takes time. That takes somebody having the ability to do that. And it's, again, goes back to resources. What do you have available as far as resources to accomplish some of those tasks? It can be quite daunting. And I don't know about you, but I just do not have to be working on weekends if I don't have to. So, all right. Anything else? Anybody else have some comments or thoughts that they want to bring up here? Okay. Well, that brings us to our next slide, which is a break. So let's take a 10-minute break. We will come back at quarter after the hour and start back up. And we'll just pause until that point, unless somebody has some questions. I should probably ask that first. Anybody have any questions at the moment? All right, well, let's take that 10-minute break and then we'll be back.
All right, welcome back from break, everybody. We're going to talk here for a minute about optimizing schedules, and that will then lead us into our lab. Now, I'm pretty sure that most of this is going to be pretty standard, probably stuff that you've heard before, but just in case you hadn't or you need some reinforcement, here we go. So obviously, most schedules we can adjust manually, right? Procedure is pretty standard, nothing really complex or anything. We're going to go through and define our area that we're looking at. Sometimes it may be logical areas, all of our, first grade classrooms, for example, may all or probably all run at the same operating hours. So we're going to define that as an area. We're going to evaluate the time that it is being used for, when it's occupied. This we have to keep in mind, of course, when instructional staff are present, not just the students, of course. And then we adjust our schedule for that area accordingly. There have been a couple folks in the comments who've stated that they have their schools broken up into as many areas as they can. This does offer a lot of versatility for being able to do our scheduling as far as being optimized for energy. Of course, it also leads to a lot of work having to do that scheduling, assuming it's not being handled by an external software. Okay, which would fall under automatic scheduling, or maybe not so automatic, but mostly somebody else's problem, right? But we're going to evaluate that area and adjust our schedules so that it matches. Now, this gets into a little bit on the energy side, like Ted talked about before our break, about things like optimized start stop or warm up / cool down sections, where if you have to manually take that into account and you're just doing that as part of the occupancy schedule, which isn't obviously the best way to do it, but definitely how some systems are set up. And in some situations, probably works just fantastically. But others, it may be a little bit energy intensive. So we need to take that into account too. If we need to manually schedule that warm-up period, cool down period, then we need to do that when we update the schedule for the area as well. Assuming it's not handled by the programming of the system, which definitely happens, right? Hopefully more often than not. Sorry. We also have to take into account any exceptions for the schedules for a given area. You know, those nighttime events that happen on a monthly basis, or those rental events that are just a one-off, and of course our holidays. And, you know, for those dealing with public school systems, that's likely going to have a lot more holidays than your average office building. So going through and getting those set up and scheduled, whether it's a one-time or periodic in-service day, or you know, a consistent holiday that's always followed, you know, those we've got to schedule whenever we can, and leave our exceptions to be those days when the school is closed unexpectedly, for example, you know, snow days, other events in town. You know exactly what I'm talking about. Okay. There is, of course, also automatic scheduling, you know, things like our warm up and cool down sections that hopefully are happening automatically. It's not, ideally, it's not something you have to manually schedule, but that it works off of our existing schedules. So the system knows that you're going to go occupied full on at 8 o'clock in the morning, and take heed of the existing conditions in the space and our outside conditions, and try and figure out about how much time we need to be able to start early so that we are up to the temperature we want to be when we hit that occupied time. And as Ted mentioned earlier, and I don't remember, maybe it was Tyler or Adam said it earlier as well, you have to be careful with optimized start stop, especially our older optimized start stop algorithms were not necessarily the most reliable devices. Optimized start stop is a hugely complex device to program from our controls standpoint, at least. So, and relies on existing data. And again, like we've said multiple times, a functional system. The sensors that the optimized start stop are relying on have to be accurate, have to be functional, and our system that we're controlling has to be functional. Let's face it, trying to warm up a space from 55 degrees to, or I'm sorry, 65 degrees to 72 is never going to work if you've got no functional heat and it's 10 degrees outside. So keep that in mind. But hopefully, and the newer optimized start-stop algorithms are better, especially those that are kind of coming down from overarching analytics systems. For anybody who has something like SkySpark or Clockworks or any of those type of systems, those optimized start-stops are significantly better than our historic ones. And every one of the big companies has their own optimized start-stop algorithm that they've figured out that is, their particular flavor. And like, again, most of the historic ones, a little bit problematic. The newer ones are getting much, much better. But knowing that your school districts, you probably have more of the older systems than the new, just kind of how it is in the public sector, right? And of course, as we've mentioned several times, as Adam Schultz is lucky enough to have, there's scheduling software. If you have event scheduling software and it is tied back into your building automation system, whether it's for climate controls or lighting or security access, that's just fantastic. That's what we were promised with the 60s and 70s smart buildings, right? That's the ideal. So hopefully you will be seeing more of that, especially those of you who have a lot of outside events that get scheduled. Regular school times are one thing. When you consistently have the classrooms full between, say 8 o'clock and 3 o'clock, that's easy to deal with. The set point tracking when it empties during passing period and then fills right back up again, that's a little more problematic, but that's something we're used to seeing. But from a scheduling standpoint, that type of thing is easy. It's those exceptions that we're having a club meeting on Tuesday nights, but nothing on the rest of the week, sort of things that are a little bit more challenging. And Adam has made a generous offer, offering guidance on how to get started with implementing that kind of project, if people would like to reach out to him and talk to him about it. And that is really a generous offer, Adam. Thank you for that. All right. Any questions or other comments on optimizing schedules? It's kind of basic, right? When you have time to do it. At least at a conceptual level, it's basic. Once you get down into actually doing it, of course, there's a lot of work there that needs to be done. All right. If there aren't questions or comments, I'm going to take over the screen share from Ted, and I'm going to show you our system that we are working on. So I'm going to just give you a general tour to let you see what we have to work with. There we go. Let me make sure I get the right screen to show you. Yeah, there we go. All right, now everybody should be seeing where'd I go? There I am. Mostly black screen with a little login here. So Ted is sending out the links now for you to be able to access your iteration of this. Not everybody gets entirely your own unit. There are going to be 2 people per unit that we have. We have 12 units. So that's what you'll be working with. This is our login screen. You will have login credentials so that everybody has their own account that they're working under with this system. You will be, again, sharing a floor. But let's take a look and see what we're working with. Of course, your login credentials are capitalization sensitive. So as you log in with that username, make sure you capitalize the L, and everything else should be lowercase. And I should actually log in as that user. So that this is what you should see when you first log in. This is the floor plan for our workspace, our lab space for this, the course of this training, the remainder of this training. Okay, we have 5 zones: north, west, south, east, and then we have a core zone. You will be assigned to be working either on the north and east zones or the west and south zones. But the core zone is here for you to look at as well, and kind of where I'll be doing a lot of the demonstration type stuff. We also have a plant and an air handler. Okay, so we're going to start off at the plant and see what our systems are here, and we're just going to do a quick tour and talk through it. Anytime you want to go to one of your other graphics, whether it's one of the zones or one of the major equipment items, just click on the word for it and it'll pop up right there for you. Okay, so this is our plant. We have a chiller providing cold water for our system. Right now, our outside air temperature is fairly low. We'll see that on when we look at the air handler. So we actually aren't running the chiller right now. And because of that, you'll see everybody's probably going to see this same error. It's a cannot read. It's nothing to worry about. It's just how this system deals with a 0 value on this particular point. For whatever reason, our flow values get a little weird when they're at 0. So it gives this weird error. Nothing to worry about, just one of those idiosyncrasies to the system. On the heating side, because it is cold in our virtual environment, we are running our heat. We can see we're supplying 113-degree water and coming back at 84. So we've got a good temperature delta on that. And we have a messed up link as well, which is awesome. Not something I normally get to talk about as much. But it's one of those things. These systems, like I said earlier in the day, are built by people. People make mistakes. It is really easy to make mistakes in these systems because typically everything is manually built. Okay, so when you have a person who is pulling data from a controller, and I'll show you this process here. If I need to add points to this graphic, I have to first discover the points in the system, which I don't have the rights to do because I'm not an admin right now. But you have to find that point, add it to the system, and then add it to the graphic. And there are a lot of spots there where you can make mistakes. And with something like a chilled water, hot water plant where it's just a single system in that building, it's not too bad to make that mistake. It's just one thing you have to correct. But when we get to our VAV boxes, our zones, it's going to be another story because you don't create each of those separately. You create one and template it and run it down to all the other systems or all the other VAV boxes that are the same. So an error on that first one becomes an error on all of them. And that's very typical with how most control systems handle that. Okay. And reminder, please stop me for questions if you have them as we're going, because I know I'm going to kind of go through this fast. I'll bring up the chat so that I don't potentially miss anything.
Now I'll watch chat also, Robert.
Awesome. Thank you. Cool. All right. So anytime you want to close out of a graphic and go back to the main floor plan, just come up to your upper right-hand corner and hit the little X box. Brings you back to the main floor plan. If you accidentally close out of the floor plan and you just see the black screen here, you can come over to your navigation tree here on the left, and you'll see this demo site 1, back 5K as the first thing. Open it up, click on BOP T1, that stands for BOP test. And your graphic here is, or your floor plan is the A_floor plan. Okay. You'll discover why I've named it that way here in a minute when we look at it further into the tree. On the air handler side, we do have a full functional hydronic air handler. Currently, we are running our supply fan at 29%, pretty low. We aren't building any static pressure, so we're just at a base speed. We have 15-degree outside air, 73-degree return air. So we are mixing that up and sending it through the system. Hot water, chilled water coils, supply fan variable speed, and our supply temp set point. As we need, we will turn this set point up and down, but that's automatically controlled for us. Okay. We'll look at one of our zones next. Our zones are basic VAV boxes. We've got a air control damper and airflow station. These airflow stations may read errors when the damper goes full closed, just like we saw in the chilled water system. We've got damper positions. The core zone damper is a little bit wonky. For some reason, it thinks it's at 0. It really isn't, I promise. Also why we're not playing with the core zone at the moment. We've got a reheat valve so that we can control the heat into our spaces as needed. And we've got a supply temperature sensor. Over here on the right-hand side, we can see our zone information. We have our zone temp here is the middle, or in the middle, cooling set point above it, heating set point below it. We also have CO2 in the space. Our occupancy schedule, we're going to see here in a minute. I'll put it up as a slide, or Ted will put it up as a slide. And anytime you want to get to a schedule, all of our zones are scheduled individually. Just click on the schedule and you'll be able to get into the schedule editor, which is something we're going to work with. Anytime you need to edit a schedule or edit anything, you're going to click on the little pad and pencil icon. And you can see now we can delete an item. Of course, I want to delete it. And we can just hit the plus to create the item. Obviously, our schedules right now are all messed up. That's why you're here, to help me fix them. When you edit something, you'll notice that your little save icon changes color so that you can save it. So be sure you do. If you do make a change, and you try to close out of that page, it will ask you if you want to save. System's pretty good like that. EA for modern software. Okay. Any questions so far? Pretty simple. Good. All right. Let's talk about our tree navigation over here on the left a little bit more. We have, at the top, we have a list of folders. All of these are our, going to be our individual controllers, effectively. So we've got one for our air handler. Ignore alarms and behind the curtain for the moment. We'll talk about those here in a sec. And then we've got our 4 zones or 5 zones, excuse me, and our plant controller. Okay. So anything that we want to find more information about, we can drill into. But here at our surface level, our highest level that has anything useful, we do have, again, our floor plan. So if we need it, just click on it. We also have some trend logs. Now, we're not getting into the trend logs today, but I would encourage you to go ahead and take a look at them and see what kind of data we have. But those are all here for the entirety of the floor. Everything's right here at the top. This is mostly power, though we do have some zone temperatures here as well that we can see. But if we want to look at more in depth at a piece of equipment, like let's look at our east zone. We click on that. Right at the top of the list, we have our graphic. So if we need to open our VAV here, we can see our dampers at 30%. We've got 635 CFM of airflow. And we've got our hot water valve halfway open so that we're warming our space up. Okay. We do have all of our individual data points down here below the graphic. If we needed to override something like our damper position, we could click on it, put it into manual mode, make our change, and hit apply. Now, I would request that you not do that for our damper. If you want to do that for your heating and cooling set points, you are welcome to do that. But the better way to do that, of course, is going to be through editing our schedules. But we've got our data points all here lined up. Everything in this system requires listing in alphabetical order. That's why our graphics will all start with A underscore. Our schedules will all start with ZZ underscore. Same with our trend logs. That way your graphic is always right up at the top of the list, and your schedules and trend logs are always down at the bottom of the list. Oh, one thing I forgot to show you on schedules, I'm going to click on it here in the tree, but I could get to it from the graphic as well. If we look, right now we are here on our time schedule icon. When it's unoccupied, that icon is going to be red, by the way. But if we click over into our little calendar with a checkbox, we can edit and add our exception days. We can do it as a single day or a date range. Maybe it's spring break and nobody's going to be in the building. Well, except for us, because we're facilities and nobody gives us a vacation, right? Mm-hmm. Also, if you click over on the light bulb, you can see what this schedule is actively or actually affecting. So we've got an occupied point. This occupancy we can see here in the tree. We also have our cooling set point and our heating set point. These are being directly modified by our schedule. So by default, right now, we're set up for 74 cooling in both occupied and unoccupied mode. And our heating set point is set up for 72, again, occupied and heating. Or, sorry, heating in occupied and unoccupied mode. So those probably are going to be worth paying some attention to when you go through to edit your schedules, because let's face it, it doesn't do anything if we change over to unoccupied mode but have the same set point. The reason I have these set up this way is because I've seen them set up that way in the real world. The problems that I'm throwing at you here in these labs are things that I have seen personally in the real world. Be that what it may, I consider it unfortunate most of the time, because a lot of these things are really easy to fix if you know how to do it. Okay. I'm not going to belabor a bunch of details about these systems because I know none of you have this system at home. But it gives you an idea of the kind of things that your scheduling software is capable of, or your BAS is capable of. And if there's something we can do here in this system, then you can do it in your system at home. If you don't know how, that's okay. Find somebody on your team that does know how, whether that's a senior tech or a supervisor or just somebody who's been around longer than you have. Or if you need to call your contractor to find out, hey, how do I change the set points associated with this schedule? There's nothing wrong with not knowing. It's just how it is. And that's why we're showing you all this stuff, is to make sure that you know or have a better idea of what you don't know, how to move forward. Okay. I think that's everything I wanted on the schedule. Of course, like I said, take a look at your trend logs. You will see some trend logs that are named very close to the same. We've got short and long. Our short trend logs are oddities. Everything is being logged on a 1 minute interval with these. Okay, which is good for troubleshooting, but most systems aren't going to be able to log that much data for you, not at that frequency. So we also have our long data, which is every 15 minutes, which is much more normal for what you probably have at home. Okay, I gave it to you both ways so you can see it both ways. For anything like when you make a set point change and you want to see what's happening right now, I'd encourage you to look at the short trend logs. Okay, just because, you know, we're only here for a couple of hours, and if we're only in lab for 1 or 2 hours, that 15-minute logging period becomes real hard to see anything on. Okay.
Question,
Fire away.
Robert, is when we're looking at that trend data, is it really live? Is it being updated realistically?
Great question, Gene. Thank you for asking it. So right now this graphic is static. So if I were to leave this graphic up for the next 5 minutes, it would not change. But if you want to see the most recent version of the data, come up here to your arrows. Here we've got obviously left and right. Just click the right hand arrow, either the just forward one or the fast forward one. Either one will bring you to the most live version of the data. Great question.
Yeah, so it doesn't automatically update the screen. You have to manually go and move over there.
Correct. The graphics are a different story. The graphics are going to automatically update for you. I believe they are on a 15 or 30-second refresh rate. The data coming from our system is coming every 5 seconds, but it's not really economical from a computer processing standpoint to refresh our graphics that much. So, but if in doubt, refresh. Either close the graphic and reopen it, or you can reload your graphic, however you do that on your web browser. Okay. Be warned, if you do reload the web browser, it may make you log back in, which happens. That's okay. Last thing I think I had specifically to talk about, I want you to focus on the schedules to start with, but when you're done playing with the schedules and looking at the system in general, because I do want you to just kind of wander around and see what's there, I want you to go to your alarms folder. Okay. In the alarms folder, I have a very artificial set of alarms. Okay. We have an alarm value up here at the top that you can just turn on and off into normal and alarm to make the alarms active or inactive. Okay. They are all on a 1 minute delay. I couldn't make it any shorter with this system. This system makes it be at least 1 minute. I found it a little frustrating, so if you do, I'm not surprised. Okay, but I want you to turn these alarms on and off. I want you to click on them and dig into them. You can see right now this alarm is inactive. We can see what our conditions are for the alarm on the next tab over that looks like the stack of bricks. We can see our notes and what our feedback when the alarm goes off and goes back to normal are. Over here on our email, if we had email set up, we could send this out as an email alarm, which of course is one of those most handy things. While you're investigating these alarms, I have 1 good alarm and 4 bad alarms. Okay, I want you to look at those and investigate and try and think why I as the BAS programmer, believe that the one is good and the others are not good. Okay, your alarm console shows up down here on the bottom. It's right now, mine has an active alarm. So it was flashing red. And when I go to it, I can see what my active alarm is. This is our alarm console in this system. The alarms themselves will all individually tell us when they're active or inactive. But we also have the console if we have multiple active alarms, which when you turn on your alarm value, you'll get multiple active alarms. Okay. Does that make sense to everybody? And I need some positive feedback here. Yes, it makes sense. No, it doesn't make sense. Ask questions. Because when we get into the lab, you'll have questions. But I want to hit as many of them as we can on the front end.
Got 2 thumbs up here, Robert, saying it's good. Adam and Carlos both said that.
Fantastic. Thank you. Gene, I see we got a thumbs up from you. Awesome. Damien's got a thumbs up. Good. Okay. I'm going to stop sharing here real quick. All right. So now, Ted, you got all the links sent out, correct?
All the links are sent out. I even gave Peter one.
Fantastic.
We had 18 people I sent it out to, including Yash, by the way.
Perfect.
I did not grab one. And basically in the background here doing things. So
Yeah, you can play with it whenever you want.
yeah.
Fantastic. All right. So in that information that we sent out, you will have a web link. That should be the load. There we go. That first thing, that link should be HTTPS. This is going to take you to your web login page. So just open a tab on your favorite browser, Chrome, Safari, Edge, Opera, whatever you like. Go ahead and open up that tab. Use your credentials to log in. And then you'll notice the units that I specifically want you to work on are also copied in there. North and East units or South and West units. This is specifically for, for the schedule. Feel free to wander around and look at anything else in the system. Click on things, see what they're doing, right click, left click, see what you can see. I have backups of all these databases, and these are virtual buildings. There is nobody in any of these zones. There is no equipment that you can actually damage, but it is a very realistic and detailed simulation. So as you make changes to set points, you'll see dampers and valves move accordingly. You'll see the air handlers speed up and slow down. Our trend logs, you can see our power usage. If you want to look at that on more than just one device at a time, we've got it all totalized. That's what's hiding in that behind the curtain folder, just some background calculations that if you want to look at them and see what they're doing, go for it. But they're nothing specific, nothing special.
And I just want to ask, if anybody did not get a link, let me know in the chat, okay, and I'll get your link. But I think I got everybody. I see that Adam Sini might have an IT issue, so in getting on.
All right. Gene, you had a question or comment?
Yes, quick question. So the assignment is to, I hear schedules and do we have an assignment to change schedules according to, are we getting specific information or is the assignment just to get ourselves used to the platform?
The assignment is both of those things, to get it used to the platform and to change your schedule to match this. Let me put this in the slideshow. There we go. So don't worry about the core zone, but if you're on the north and east ones, there's your scheduling. South and west, there are those. That answer your question, Gene?
Excellent. Thank you.
Perfect.
Is that every day of the week?
Yes, that is our standard weekday schedule. No occupancy on Saturday and Sunday. Another great question.
I just put the schedule in the chat.
Perfect. Thank you, Ted. And as you run into issues, as you run into questions, please ask. I have access to all of the systems and can jump in at the same time that you're in there and be looking at the same thing. And we may, when you ask questions, a lot of times we want to talk about them in general, so we'll put them up. But for the most part, I'm going to do my best to shut up now and let you work. You said you gave Rodney one too, Ted, right?
Yeah, but he had to take off, so I gave it to Peter.
Fair enough. I will add a comment for those of you watching this later on as a recording. We do have this system up and probably available while you're watching the recording, as long as it's before our next class, which is May 16th. As long as you're in this week time period, you can shoot me an email and I can get you access set up to one of the systems so that you can go through and experiment as well. You may not be able to edit the schedules because they may already be done. We do have more folks signed up for this training than we were expecting, and we only had a limited number of these that we could do. So. I'm going to stop sharing my screen since Ted has the information in the chat, but we can start sharing it again at any point if someone needs. But it's easier for me to see the chat and everything without screen share. And don't feel rushed with looking around at stuff and finding things and asking questions. This is what we have scheduled for about the next hour, unless everybody gets done with everything they want to do before then. Okay. So when you are done, please drop a message into the chat to let us know, so that we're not just sitting around because everybody's done and Ted and I don't know. Because we do still have alarms to finish up and deal with today. Adam, why am I not surprised that you're showing up as the first one done? Just being good natured, not throwing shade, man.
No, it's fine. I mean, I'm trying to be a proactive person all my life. I believe you get out what you put into everything.
There you go.
Oh, yeah.
Well, feel free to wander around the rest of the system and see what else is going on.
Will do. I mean, I've still got my normal duties that I'm working on in tandem to this course. Unfortunately, I'm a one-man operation.
That's right.
I do have a controls tech, but he actually falls under the maintenance supervisor.
Gotcha.
Yep.
Jessica asking what I want done with the alarms. So the goal with the alarms is to investigate, play with them, see what the different settings are for them, see what we can, what makes them good alarms or bad alarms, because that is going to be our next topic of discussion is alarms.
Hey, Robert,
Yes, sir.
I missed it. I'm sorry. I've been kind of doing two things here. Did you say anything about them being able to work on this outside of this window on Friday? Can they work on it between now and next week, or?
Yeah, you do have access to this. It is up between now and our next class. Actually, it will be up between now and our last class. So if you run into a question and you want to go take a peek at it and poke and see what can be changed, what's going on with the system, especially as you make changes to things like schedules, if you want to take a look and see what the power usage looks like. Yeah, accessible as long as you keep that link handy. And if you lose the link, email me. I'll give you give it to you again.
Yeah, and I asked the question specifically because one person, because of IT, can't get on. So they will be able to grab their access information, and maybe when they go home, they can work on it from home until IT gets them set up.
Absolutely. That could be a reasonable challenge, and something I had not thought of is if the site is blocked.
And otherwise, Robert, no one has to worry about accidentally screwing up some settings or what have you.
Nope. This is a completely safe learning environment. That's why we are doing this, why we've got this simulation set up, why we're trying this, is because while we always encourage you to learn on your own building, when you have access to a building, it isn't always the easiest thing to do because there are consequences for every action you make. The consequences may be as simple as a hot complaint or a cold complaint, or they may be a little bit more energy usage than should be there. But you can also get consequences so bad where you break equipment or cause the building to be shut down for a day. This is not one of those situations. It is completely safe in this environment to make mistakes. So there is literally nothing in this you can screw up that I can't fix with a few quick keystrokes. No equipment to break, no occupants to piss off and hunt you down with pitchforks and torches.
Well, that's half the excitement, isn't it?
You might like to be chased with pitchforks, Larry, but I don't.
Oh, only on Halloween.
There you go. And I did like the person earlier, I think maybe it was Jessica who said it, that sometimes it feels like we work for the complaints department, not the maintenance department. Nobody here to write in those complaints, so you're good. Great question though, Larry. Thank you.
Yeah, this is Damien. I'm not too familiar with all the different BAS automation programs. This contemporary controls, is this a fairly common control system?
That's a fantastic question, Damien. So Contemporary Controls is a company that's been around for quite a while. They're based out of Illinois. That's where their headquarters and manufacturing are located. The system we are working with is called BASView 3, BASVIEW 3. And it's a standalone application, appliance. All of the software is hosted on the machine and it's all accessed via web. It is, however, not remotely common in the industry. It is a kind of small facility solution, something like a strip mall or a small nonprofit institution, something like that. So I doubt anybody here has ever heard of it before unless they've talked to me about it specifically. We use it for our training because it is particularly affordable for that purpose. And again, everything is web-based. So if we wanted to get into how to build graphics, we could do that with this system and nobody would have to buy or download any additional software that would piss off your IT departments. Did that answer your question, Damien?
Yeah, so the contemporary controls is the hardware then, and then the software would be the back view.
BASView 3. So
back.
it's actually kind of a combination. While folks are working, I'm going to jump to Contemporary's website and I can show you. Please note, I am not trying to advertise this product to you. I actually don't think it's something anybody's going to want to install in your building. But if you've got a particularly old system, this might be a solution, I guess. But that's a really complex thing to say. So this is the BASView 3 module. It's about 4 inches square on a side and about 1 inch thick, and sits and acts as a building level controller. It has the ability to do your schedules, your logs, alarms, emailing out alarms, all of your kind of basic functions. I will tell you from experience, it is not the most friendly piece to set up originally. Because it is all web-based tools, it does not feel as refined as most of your modern control systems do from a software standpoint. So what you are doing right now, the work you're doing on the web, these are, you're actually logging into half a dozen of these on the Lawrence Berkeley National Lab campus up at their Flex Lab. And we are feeding them that simulated data that you are working with. But yeah, this
Yeah,
is the appliance.
I get it.
I like
Okay.
Contemporary Controls as a brand, by the way. They've got a lot of networking tools specifically oriented at building controls. And they've got some building controllers that are really good for teaching on. Also, their main controllers are a lot more developed than this particular appliance for building usage, if you're interested.
Hey, I just let folks know. I mean, actually, I changed the heating set point since I believe we saw, I don't know, 10 or 15 degrees outside. I thought it'd be more comfortable at 70 instead of 68, and I actually saw the improvement in 1 degree in the zone temp, and I see an improvement in the supply air temperature for heating. Yeah, this is really neat.
Awesome. Glad you were able to see that kind of reaction. That is one of the things that's maybe a little bit idealistic about this simulation is all the equipment is actually really properly sized for the loads that are being applied. It's a little unrealistic from that perspective because how often do we actually have real world perfect scenarios? But it gives us a playground, and that's the main purpose for it.
Yeah, I think, just so everybody knows, this is a pilot setup, and Robert is the one who has made this all up in coordination with the Bob Test people. And is it all from LBNL? I don't
So
recall.
the main project is based out of LBNL. The project manager and the developers are all there, but the models have mostly been developed by LBNL, but a couple of the other national labs have contributed as well.
Yeah, so it's something where you bear with us a little bit because some of this might take a little bit of us working through things, okay? But on the flip side of that, kudos to Robert for getting us up and running. And I think we'll have great potential with this in the future for working on trainings like this and for people to learn things to understand their own systems better. So
yeah,
good deal.
I mean, how often do you get to play around with a building with effectively zero consequences?
You don't.
And I am logging any of your questions, by the way, that I find useful, like Jessica, your question on where's the outside air temperature. So often that's a data point on every graphic in our systems. And that's something I missed when I was building this one. So the next, you won't see it in this training, but if you join us for another training in the future, I'll be fixing that and making sure that outside air temperature is present on every graphic.
So on the building control systems that I use, every minute of every day has a schedule attached to it. So it looks like we're just setting the schedule for when we want occupied mode, and it's just assumed that all other times are unoccupied. Am I understanding that right?
That is correct with this system. Yes. You are specifically defining that start and end time for occupied periods. So it's a lot more like you would expect to see it from a modern smart thermostat perspective.
Okay.
Just so everybody knows, just if our cameras are off, we're listening still, so you can speak up and either Robert and I will be there to address your question or comment, whatever.
Absolutely right. We are here for you.
On the air handler, I've been messing around with the cooling valve position, and it doesn't seem to be changing the like supply temp or anything like that.
That's because right now we don't have any chilled water.
Oh, okay. Makes sense. So I suppose if I mess with the heating valve, we might do something.
Much more likely, yes, sir.
I was able to see that change in the trend data. That's where I noticed my actions of changing the set point is within the same area that I was working in.
Fantastic. Were you looking at the trend logs for that zone or for the air handler or the building or what?
For that zone.
Okay.
And so since it was just conveniently at the, bottom of the tree, I made the changes and, right in that zone and just went to the bottom to track it. And
Gotcha.
it made a change.
Fantastic. I'd encourage you to go ahead and jump into the air handler and see if you can detect where that change was made there. See if it had any effect there as well. Technically, it probably shouldn't, but if enough of the zones call for heat on this particular system, it will start upping its discharge air temp at the air handler.
Not exactly sure how to change the zone heating set point, the active versus inactive.
Gotcha. I will bring that up and we'll take a look at it.
I was just going to ask that question.
Awesome. All right, let's see if mine wants to let me continue or if I have to log back in. Here we go. All right, so when you want to change your heating, cooling set points, step one is going to be to click on the little light bulb while you're in your schedule. Pops up here. If you haven't already clicked on your little notepad thing, click that. Oh no, you don't have access to change that.
Ah, that's a bummer.
Give me a minute and
Okay.
I'll fix it. So that's why you couldn't figure out how to do it, because
Right.
I didn't give you access.
Keep
I'm gonna
finding those
stop.
switches that he can correct on the fly here. That'd be good.
That's right. Got to keep me on my toes, right, Ted?
It was
That's right.
active for a little while, and then it became inactive again. I don't know
Huh.
if it's something I was
Weird.
fooling with or what.
I changed through the tree, not through the schedule.
So you changed the set points themselves, Gene?
Yeah, so there's a
so
cooling and heating set point, and I assumed that
no, your assumption was correct. Those
yes,
absolutely are the cooling and heating set point for the zones. But the
yes.
schedule, the schedule changes from occupied to unoccupied or the other way, it will overwrite whatever value you put in.
Ah, that makes sense.
So give me a moment, everyone here, and we'll get you upgraded to being full-on administrators. And as far as what you want to change those set points to for occupied and unoccupied, I will leave that up to your discretion. All right, I think that should be just about everybody on your administrative rights. So Gene, Damien, if you two wouldn't mind trying to change those set points again, when you click on your little edit icon, it should pop up a little window next to those set points that'll let you edit them now. Looks like the same little pen and pad icon. If it doesn't show up right away, log out and log back in for me. Gene, Damien, did that work for you?
Yeah, when I logged back in, it just showed the schedule's active. I didn't have to change anything. But I can edit the occupancy now.
Good. You said you cannot edit the occupancy?
Oh, I can.
Okay, good, good.
Whereas I couldn't prior to that, logging out, logging in. So thanks.
Perfect. Yep, good point, Adam. Make sure to save. When I see your comments in the chat now, Damien, thank you. How about anybody else? Anybody else have any questions, comments, problems?
We'd also like any feedback as to how valuable this is too.
Absolutely.
I don't know if that's something there you're gonna be putting evaluations or not, but yeah.
The question, comment, the demo site 1 has a running time of 6:35, 6:36 a.m. right now. And so when we look at these schedules, are there any correlation between the start time and the end time for today? And how do we know what day of the week this is on if it gives us that?
Great questions, Gene. I will share screen and we'll look at it. Because you're right, that is something I didn't address. And so I'm just on my schedule here. But if we come down here to this little gear icon in the bottom left and click, we get a lot of different options. And one of these, I think under edit settings, we've got time and date settings. So this would fall into that category of making sure that our system clock is on the right one. Right now, mine is showing 1:39 p.m. I'm Central Time Zone, so that's accurate. If yours is not accurate for your current time zone, go ahead and make that change.
Robert, can you go back and show? I missed that.
Yeah, totally, Dan.
Thank you,
So,
sir.
just as you're in your general login,
Mhm.
down here in the bottom left-hand corner, there's the little gear icon.
Mhm.
Go ahead and click on that. Come up to your edit settings, time and date settings.
Got it. Thank you, sir.
Not at all. And good eye on that, Gene. That was good. I should have mentioned it before, but I forgot about it.
With the trend data, is it just we don't have enough time to really view anything, or am I missing something? I'm just kind of highlighting the end of the graph there to zoom in.
So make sure you hit that right button, the little arrow up above. Make sure you hit the right, and make sure you are in the short trend log if there is one. If you're looking at like power settings or something, or power usage, something like that, you're only going to see the 15-minute. But if you're looking like your zone temperatures, discharge air temperatures, stuff like that, click on the short version. That'll update once a minute. So your time didn't change, Kaylee. Let me log in, see which unit you are in. Mhm. You- no. Carlos has a good suggestion there, Kaylee. Go ahead and log out and log back in, see if that does it. Awesome. It's always nice when something simple like that works. When you log out, it's asking you to select a theme. Well, that's a new one on me. Just a second to see which one you are logged into, Jessica, and I'll see if I can see what you're seeing on my end. May have to give you permissions to share screen if you're willing to do that, though. How interesting, you're in the same one that Kaylee is. So in that situation, Jessica, I would suggest if you're able, go ahead and close out of that browser window and relaunch from your original link to log in and see if it still asks you that question. I just logged in under the same account you're using and didn't get it. So it may be a little bit more complex of an issue than that. But we'll see what it is. If that doesn't work, we'll go to the next step. Oh, or it may have hit the little paintbrush icon to the right instead of the login button. If you tab one too many times, it'll go to that instead. Jessica, would you be willing to share screen so I can see what is going on with yours? And if it won't let you, just have it send the request, or I'll actually I should be able to do it here. All right, Jessica, I promoted you to a temporary co-host so that you can share screen.
Okay, give me just a second here. Can't remember how to do this on Zoom.
Right? We all have to deal with so many different platforms, don't we?
Okay, I think. Can you see that?
Yes, I can.
So I can click on that the only thing I can click in the screen is on the bottom right. There's a tiny previously on the left side I had a complete menu bar with all the settings returning to the floor plan, and it just, I don't know,
Right.
disappeared.
Well, that's exciting, isn't it?
The only thing I can see is this little change theme box. So I don't know if I changed something in the settings, and I can't tell if I did.
I doubt it was something you did. Let's start off. Let's go ahead and try and reload that page.
Okay. Doing this directly while sharing.
Click the arrow that looks like a curve in the bar, push F5. There you go. Do you have a different browser other than Safari?
This is Safari.
I think your browser right now is Safari or some kind of iOS one.
Yeah, Safari.
Yeah.
Yeah, so the issue is definitely not anything that you have done. I need to reboot this particular controller.
Okay.
That's one of the other things about these is they're a little bit temperamental. I apologize for the inconvenience on that one.
Oh, no worries. I'll just stop sharing. Unless you want me to keep it up.
No, you're good.
All right.
You'll be able to tell me if when I rebooted it works or not. So that means I will. Quick question for you, Kaylee. You can answer on audio or in the chat. If there is anything you are doing that you need to save before I reboot, because you and Jessica are working under the same controller. Okay, thank you very much. Alrighty, Jessica, that should be rebooting now. We are going to take a break here in about 8 minutes. It'll be another 10-minute break. And then we will get in to finish up our lectures at about 10 minutes past the hour. So if anybody wants to take a little bit of a long break, go ahead. Jessica, that controller should be back up and running right around the time that our break starts. If you want to go ahead and log in to continue working on stuff, you're welcome to do so. If it does keep giving you problems, try opening it in an incognito window. I have one of our others that shows up the same way for me until I hit it from a different browser or in incognito mode. It's something weird with some of these controllers. Hey, awesome. I'm glad it worked. All righty, folks, I think we're going to officially hit a break here. We will reconvene at 10 minutes past the hour to finish out our discussion on alarms. Of course, the system will be up and running. So if you want to continue working on your system, you are most welcome to do so. But we'll be back at 10 minutes after to continue with lecture. I'll be in and out, so if you've got a question and I don't answer right away, just ask again in a minute.
There we go.
Alrighty, so we've talked about our schedules for the day. We've gone in, we've edited our schedules in our system. We will be looking back at what we did, not well, a little bit next week when we talk about trend logs, but mostly in 2 weeks when we talk about energy usage. And specifically, we'll look back and see how our schedule editing has affected our energy usage for our spaces. Okay, we'll go through and get to do all those fun calculations and everything. But for now, we'll finish up our discussion on alarms. So, next slide, Ted. All right, alarms, we get alarms all over the place, right? Outside the BAS, they may look something like this. We've got an alarm tower, a loud horn, strobe light, and then a fire alarm horn and strobe combo. This is pretty standard for the kind of things that we see. The tower light is a little more common on the industrial side, but these are all very viable sources of an alarm, particularly the fire alarm, obviously. But in historical screaming user, yep, that's a great alarm, Adam. I love it. I love it. But in historical setups, this was exactly the kind of thing we would use. And obviously, there are still some places that we use these types of things in our modern systems, especially things like fire alarms, refrigerant alarms, anything that's kind of that health safety category often gets an audible and visual alarm associated with it. One of the campuses that I worked on had a series of old buildings that were officers' quarters. It was a converted military base that became a school. And they had a row of these officers' quarters that all had steam boilers down in the basement. And for literally decades, they had a red light hanging on the back of each of those buildings. They all had a shared alleyway so that the engineers at night in the wintertime could drive down that alleyway or walk down that alleyway and just visually see if everything was okay in the buildings. So these types of alarms may seem outdated, but they're still absolutely valid and widely used. Next slide, Ted. But of course, most of what we deal with nowadays looks more like this. We're dealing with alarm consoles in a web or programming tool interface for our building automation systems, or we're just getting the text alerts or email alerts to an alarm that, often show the basics of the message, but sometimes maybe a little bit truncated, especially as it comes to text. But this is where we see them. These are a couple of different systems here. We've got Niagara up at the top. I think that's either a skin over Niagara or a Siemens there in the middle. And then we've got more of a kind of an industrial human machine interface type, like we would tend to see on maybe a chiller or boiler, something like that. So these are the types of alarms we see in building automation. And of course, the question is, what do we use them for? Well, that seems like a silly question, right? Failures. Pump failures, fan failures, VFD failures, generator failures. Adam mentioned it earlier, when controllers drop off on communication, especially building level controllers. We want to know when that happens. So we send out alarms. But there are lots of different things that we can use alarms for as well. We can use them as periodic or reminders of periodic maintenance if we need to. Maybe you don't have a maintenance management system or a CMM, in which case you can use the BAS as a way to do that. But there are lots of different things that we alarm as well. low and high temperatures in spaces or on air handlers or chillers, things like that. Next slide, Ted. So this is a question that, oh, go ahead, Ted.
No, I was just opening up my audio and video. It's on.
Gotcha. So I propose the question to you, and I expect some mixed answers here. Do you find the alarms in your system at home useful?
You can go ahead, put it in the chat, or open up your mic and say something.
Either one, whatever you prefer.
So Dan's saying yes, he's finding them useful. Maybe you can also just say a little bit about what type of things you find useful about alarms.
Yeah. And if you're
Something
putting it
else.
in the chat, do me a small favor and make sure you're sending it to everyone and not just sending it directly to Ted. Because if he's the last one that sent you a direct message, it will go to him and nobody else will get to see it.
Yeah, that is happening. So
It's a way to make sure your system's operating as anticipated. So yes.
So yes, awesome.
Also might make you aware of issues ahead of time rather than when nothing's working.
Certainly can. It can be used as an early warning device. Absolutely.
I see Gene put a comment in about the alarms aren't valuable for him right now because of the state of his existing system.
Yep. And that is definitely an answer that I've gotten in the past, is that there are just too many of them. No, it's not useful. We completely ignore it.
Yeah, and like Adam says, it's noise, it's overload. And that's what happened at MATC. With a million alarms in there, you're just not going to pay attention to it.
Yep. Yep. Too many in these complex systems. And that's valid feedback. When these systems get designed and installed, you right out of the box, you get a series of alarms that are a combination of whatever the design engineers think you should have and the building control technician who has done the programming, kind of their best case, what they're used to doing for alarms. And
You have to work with the contractor, assuming it is a contractor doing the work and you're not doing the programming.
Yep.
I'm putting my own in, so I mean I know how to do it, but I've talked to Pritchett Controls and they told me in the past, there were complaints that the alarms were too frequent and going to too many people.
Yep. Yeah, and to note what you said earlier in the chat, Adam, alarms a lot of times require some tuning. From the initial setup as we do retrofits as things change. Absolutely.
I'd also go a step further and make sure you test your alarms and they actually get sent, because we had that monitoring system I sent earlier, didn't realize that it had a grace period subscription. And once that year went up, we weren't getting alarms and we definitely had an issue in our data center.
Yep. Yep. Testing is another big thing that I've got a couple of points on what we need to have to make slides useful, but I can never overemphasize testing your alarms, especially critical alarms, because like you said, if they're not getting where they need to go, are they being useful?
It should also be documented who's getting these notifications somewhere, because we found that in a lot of cases, the alarms were going to accounts of people that retired 10 years ago. And these systems don't offer the bounce back or anything else that you see, typically with email and other communications, unless you go in and look and see that the alarm did not get sent.
Yeah. So,
but if there's an active mailbox willing to receive it, doesn't mean that someone's reading that email anymore.
That's true. And on older systems, we used to use things like old Gmail accounts, old Hotmail accounts to be the originating source for those systems before it was a built-in feature. And nobody ever checked those email accounts except when things failed. So you never got there may have been a bounce back that there wasn't somebody there to catch that alarm, but it didn't matter because nobody was looking to see that bounce back.
I like to design things like user agnostic, make like one shared mailbox, and then create rules off of that mailbox. That way, when you add new users and stuff like that, you're really only modifying one account.
That's a good idea on how to do it. Of course,
If you're a Microsoft shop and you have the right licensing to do that.
I was just going to say, as long as you have IT who's willing to cooperate with something like that and work with you.
Well, that's where the donuts come in.
There you go. That absolutely. Make friends with IT. Whether you like them or not, make friends with them because you are reliant on them. They are also reliant on you. And yes, I've had that argument with IT before. And yes, facilities does win when you turn off cooling to their data center. They tend to get far more willing to work with you, but it's only for a short period of time. So
I mean,
yes,
you got to have power to run a server.
Yep, you can win that argument, but it's not usually in your favor to do it that way.
I'd also say, I don't know what your guys' school structures look like, but definitely become friends with your BSMs because those are building service managers. Those are your boots on the ground.
Yep.
Well, look at some of the other comments in the chat, Robert, and I'm seeing a couple things that come to mind. It looks like a couple people have focused in on critical systems or important systems to them to take and filter for those alarms and or just have alarms on those systems. And so that's a good approach to it, because you can't always grab everything, right? So you may as well
100%.
grab the things that are critical or important. One person's talking about trying to filter through for things that freeze. That's Tyler, and Dan's talking about the big piece of equipment, chillers, cooling towers, stuff like that. So that's also, I think, a very good approach. Better to focus on a few things and let some of the other stuff go by than not have so much coming at you, you just can't do anything.
Absolutely. And Jeremy made the comment that they've got a third-party monitoring company that will call out the alarms for critical stuff. And I've definitely seen that in the past. And there are times when that can work really, really well. And there are times it does. And for some institutions, it may not work so well. I've seen some institutions that funnel all of their alarms to whoever their security monitoring team is, because if they've got somebody there on staff 24/7 watching the security cameras and, alarm systems there, they can also watch your HVAC systems and call out on critical alarms for that as well. Again, sometimes it works. I know not a lot of schools have somebody monitoring 24/7 like that, but it's an option. But we've got some great comments there. Let's go ahead and hit the next slide, Ted.
All right.
So these, to me, these are some of the key items for our alarms, our attributes of the alarms. And again, like Adam said, test your alarms. Absolutely test your alarms. But first thing we've got to know is the conditions for the alarms. Those have to be set up properly. And if anybody noticed on those bad alarms in the system, and yes, we will revisit those next week, so you can take a second look at those if you'd like. A couple of those alarms did not have good conditions. You know, either the activation condition or deactivation condition, normal, return to normal, whatever you want to call it, were not properly set up, so that there was actually an error on the alarm. If you clicked on the alarm, the main page said, "Hey, there's an error with this." Also, it has to be reasonable things. If you have something like a temperature-based alarm on something that's got an adjustable set point, you may want to have that alarm, that point, to adjust with the set point. Not directly on it in most cases, but a little bit of an offset, or maybe a lot of offset, or just a really wide range. It's really dependent on what you're trying to do. But those conditions, both when it's going to go into alarm and when it's going to come back from alarm, are really important to determine, because those are often the things that are going to decide whether something is at its base a good alarm or a nuisance alarm. If you have things that are set up too sensitive, especially if you're running temperature alarms or pressure alarms, if they're too sensitive, those alarms go off all the time. Okay. And usually when you are setting up those conditions, you also have time delays set up for that. So it has to be out of its range or in a failure mode for a certain amount of time before the alarm generates. All the alarms for our system were set at 1 minute. That's mostly for training purposes. There are some alarms that you want to generate and send out immediately or almost immediately. I almost never went on anything with less than a 30-second delay to deal with any communication bugs in the system or anything like that. But I remember at the beginning of today, someone mentioned that they get alarms out of their air handlers almost every morning. And if they wait just a couple more minutes, the alarms clear out on their own. That's an instance where maybe we need to widen that time period to let those units come up to speed and reach their set points before we go into alarm, because you know already that they're nuisance. You just know to ignore them, so they're a minor inconvenience. But a new technician may not know that. And that's one of the challenges with those. Also, your messaging. Your whatever message you put out with your alarm, it needs to provide enough detail to send the person to the right place. You know, we want to know what piece of or what building, what piece of equipment, and what device on that piece of equipment. So is it building 3, air handler 4, supply fan? That's a good basis of information. Assuming you only have one building 3 and one air handler 5. Okay, that's a naming issue that we do run into in buildings, especially after renovations. I've been in one building that had 12 exhaust fan 1s because they all got renamed. It was the only exhaust fan on that particular renovation, so it was exhaust fan 1. Really irritating. Work with your engineers. Anyway, you need to have a clear message about what has happened. If it's a temperature out of range, say that. If it's a fan failure or a VFD failure or a pump failure, say that. It puts your technicians, which often is yourself, in the right place to be able to deal with that issue. You do have to be a little bit concerned about being wordy. It's less of a problem now than it used to be, especially with texting alarms is where the big issue is. If you've got a big long message, sometimes the entirety of that didn't come through on a text. And now, of course, we just open up a web browser that's handy and jump to the alarm console to get the full story. Or we go to our email that also got the alarm and get the full story. But like I said, used to be a much bigger issue. And with older systems, it still may. But where you can, include instructions. If you looked at that, what I called a good alarm, it had a lot of instructions. It had advice on troubleshooting, what the failure was. So sometimes, and yes, I fully acknowledge that's a lot of work to do when you've got a lot of alarm sources. Okay. But a lot of that messaging can get copy and pasted down once you create it originally. You only need the troubleshooting tools for 1 or 2 different types of fans. Pumps are going to be real similar, so you can reuse a lot of that type of messaging once you create it. But it still is work to set up, and I acknowledge that. But for when we are technicians who have experience with troubleshooting, we know the building, we can really kind of tune things in and help out new technicians so that they have an easier time than we did when we were first learning a building. Okay. And I know there's something to be said for job
Security,
sustainability. What's that, Ted?
job security.
Security. Thank you. That's the word I was looking for. Yes, job security is important, and I fully acknowledge that. You don't want somebody coming in to replace you when you don't have anywhere to go. But remember, job security works 2 ways. If you're the only person who can do your job, you are correct. It's really hard to fire you. Not impossible, but it's really hard. But if you're the only person who can do that job, it's also really hard to move anywhere else in the organization. So just something to keep in mind from that perspective. And I imagine it's something that most of you already know.
Besides that, by sharing information, you grow. You can grow into other, maybe more interesting positions. So I, in my experience, have found that trying to quote unquote protect my job, protect my quote unquote intellectual property has at best just left me neutral, but typically I'm worse off by not sharing than sharing.
Yeah, absolutely the same experience here. But anyway, back to alarms. So we've got our conditions figured out. We've got our messaging figured out. Next up, we need to prioritize. For those of you who are getting massive quantities of alarms on a day, you look for alarms from your critical equipment first, right? You look for your chillers, your cooling towers, your boilers, your air handlers, your generators, your data center alarms, your freezer full of the kids' lunch alarms, because they are critical alarms. So your alarm priorities need to say that. Whether it's a color code based system and it's a red alarm, or maybe it's a high priority and priority number 1 alarm, however the wording for your system is. Or maybe it's an alarm instead of a warning, or just a informational heads up. We can use alarms for lots of things. Like I said earlier, you could use it as a reminder for some maintenance with your system if you need to. You just need to make sure, if you're doing that, that you set it as a low priority so that you, again, don't get swamped with 1,000 critical alarms. Well, when 1,000 critical alarms show up a day, what's really critical? You've got to dig through and find out, or you end up just ignoring the system. Okay. Last item I've got on the attributes list, besides testing your alarms, and this last one can help with that testing, is escalation. Okay. First off, who are we going to send this alarm to? Who is our first stop? Okay. Is it the technician in the building? Is it the principal of the building? Who gets the alarm first? Okay. If they don't address it within a certain amount of time on critical alarms, you need to draw somebody else's attention to it, right? You know, if your building technician is on vacation or out sick or is dealing with some other emergency and doesn't start dealing with the critical alarm, you need to move it up a step. Maybe building tech is your first stop and principal is your second stop. Okay. Or your building manager, or maybe you are the second stop at the district level so that you can dispatch it and move it out. And most modern control systems, I know the older systems do not have this functionality. I understand. Or it does have the functionality and it's so terrible to try and implement that nobody ever does it. Believe me, I've dealt with both of those types of systems, and yeah. But it's something you need to think about, most especially with your critical alarms. Okay. And when you do set something like escalation up, you need to follow through again with the testing. You know, give the people on the list a heads up, say, hey, I'm testing this alarm today. Could you let me know when you get the message? Okay, it's just a test. You don't need to do anything with it. Matter of fact, I don't want you to do anything with it because I want to see what happens after your step. And make sure that the alarm gets to all the people it's supposed to in the time period it's supposed to. The number of hiccups that you can find doing that, either in how the system or the alarm is initially set up and how it ends up cycling through, can be really, really informative as to where your problems are. I worked with a maintenance supervisor who would often generate a fake alarm on a piece of equipment. He would just randomly walk into a mechanical room and he would put the VFD he would shut it down on an air handler. You know, just shut down the supply fan. And he would stand there in the maintenance or in that mechanical room until somebody showed up to deal with that problem. A little bit of an excessive way of dealing with it, but I can't say it wasn't effective. It did show who was looking at their alarms, who was ignoring their alarms from a personnel standpoint. And there was more than once when he found a communications issue because of aged software, where a driver got outdated or a license that expired, things like that. It can be an effective tool. Everybody hated that he did it, but you know, it did work. Does all of that make sense? Are there any other things we should think about as far as important alarm attributes?
Not see anything show up in the chat.
Reactions to some previous messages, it looks like. All right. Next slide, Ted.
He's open for questions.
There we go. Anybody have any questions on anything we covered today? Or last week or the week before, for that matter, at this point?
Any feedback on the lab?
Yeah. How did you like the lab? Did you find working with that system interesting, useful, not useful? Did we spend enough time or too much time?
I thought it was beneficial. Um, I, our school system, Rockingham County Schools, has the Medisys system, and it's taken us about, I don't know, maybe the last 6 or 7 years to get everything to where we have it now. And I think we have a really good system compared to what it was before with all the old infrastructure of Medisys. Um, but I'm always, I don't have a lot of graphics, and I've been uh, talking to other energy managers around the nation, I should say, talking to them about their systems, and everyone seems to have a heavy ended graphics, building automation system. I'm just used to looking at data. I only have two schools that have the graphics, and I just opt to look at the data. And so by getting into this type, I'm always wondering, am I handicapping myself just dealing with data? Because there's some benefits to graphics and some benefits to just looking at the data. I guess I don't know, but um,
There definitely can be. I, I've I do a little bit of both personally. And it looks like you're not alone in having very few graphics. Um, there are some advantages to graphics. It can help you understand the relationship that some of the data has. Likewise, though, graphics can be a little bit of a trap in that if you get people who aren't experienced with the equipment in the field, they may not, if they start off looking at the graphics, they may not actually understand when they get to the field what they're looking at because they expect it to look like the graphics. And it's one of the things that I really emphasize about graphics in building automation systems. Doesn't matter whether it's HVAC or lighting or irrigation. The graphics are only a representation of what you see. So you don't get trapped by thinking it's going to be exactly like it is in the field. There are some companies that make some really beautiful graphics that absolutely are accurate to the field. And those can be really remarkably well done when they're well done. They can also be absolute garbage when they're not well done. So
It takes a lot of effort too to make the graphics, and then when you go and change something and they're not relevant anymore, you got to go back in and either pay the programmer or know how to change it all yourself, and it's not that easy.
Adam is absolutely right. Some systems are easier than others, but I've worked with about a dozen systems over the years, and I wouldn't qualify any of them as actually easy to work with.
And that comment also brings up the cost.
Yeah.
It's expensive. It's expensive to have them.
Functionality over form.
Yeah.
It was good to be able to deal with something that I'm not used to dealing with, and good job for you guys in the graphic parts of the automation. I noticed that points were clickable, and that does help, and kind of very similar to what the few graphics that we do have here. They have that expansion. So yeah, I enjoyed tooling around. Appreciate it.
Fantastic.
I've seen
Yeah.
some that
Well,
don't render properly too on certain screens and systems, and
Mhm.
it's just not a uniform experience for users.
That is one of the other things that can be a challenge with graphics, especially when you have multiple generations of projects or different buildings that were done by different contractors, or even just different programmers within the same contractors. Having consistency between how an air handler looks in one building versus another can be really, really useful when they are very similar units. So that's a very good point.
yeah. Well, to the earlier comment about having very few graphics, don't most control systems have at least system diagrams available? Right? I mean, like showing the chiller connecting to the cooling tower and all that. Really?
No, that is
No,
far from
that's
standard.
created.
Hmm.
Yep. Yeah,
I think it's
all of
generate
that is hand created. Sometimes they will have uploaded like the control drawings or the design documents in some way or other, but it is not at all consistent. It depends on the contractor and what was specified and what is paid for.
Hmm.
Like our system, some campuses have it, some campuses don't. So it's kind of hit and miss. It just depends upon when that particular system was updated and or installed, whether you get a floor diagram or any type of graphics of equipment in it or not.
And especially when systems get updated, that can be a real significant barrier to getting the graphics done.
So we ported some of the systems from one control environment to another, but the graphics for those schools still remain. So it can be kind of confusing. Like I know they're not going to be able to click on them or anything like that, but to another user that's new to our system, so that's another detriment. Like you're going to go back in and update every time something's changed.
Yep. Yep. There were a lot of times when I was upgrading old Network 8000 systems from the Signal graphics, where we would just take a screen capture of the graphic and clean off the point data and make it the background image for the new system.
We also changed our logo, and now every one of these graphics has to be redone.
Yep. Yep. And that's one of the things that the newer systems do have some advantages with, is they've got ways to reference files and things like that, so you can update the file and the graphic changes with it. Much more very similar to how modern web pages do a lot of things. So the industry's getting there. Just remember, building automation is about 10 years behind IT. So if you think about what your web pages and everything like that were capable of 10 years ago, that's around what we are. And remembering also that graphics is one of the lowest priority things from programmers.
And of course, Adam, when they made that logo change, they allocated costs for all the logos and all the different systems to be changed, correct? So you got money for allocated for that, right?
Of all the problems facing my county school system, the logo definitely was at the top.
Yeah.
No, so honestly, they paid not-for-profit paid to get the logo designed, but they didn't pay to redo all our trucks,
All the signage and everything.
Yeah, I redid the domain, and our one of our chief communications officers was like, "What's the big deal? It's just a couple of letters." I was like, "You have no idea." Yeah, Microsoft uses the FQDN for so many things. You break all those links. Like, I'll send all the help desk requests to you.
Yeah. All right. How was the amount of time we spent in lab? Too long, too short? About right?
I thought it was good.
Okay. About right.
Mm-hmm.
I know a couple folks got done real fast, so I just wanted to check and make sure.
I thought it was a good amount of time, especially, well, for me, I have some experience with, building automation systems, but possibly coupling that time with several tasks, half a
Mhm.
dozen, maybe 10, what's the, set point setting for, occupied heating, or, what's the temperature, what's the mixed air temperature for this? It may help to get everyone to the right places that you'd like to be able to have them exposed.
Gotcha.
Would be I think, a decent improvement.
Kind of a scavenger hunt type activity. I dig what you're saying.
Exactly.
Makes
Yeah.
sense.
I was kind of wondering if it would have made, been possibly a little better if we had broken it up a little bit where each section we talk about things that we jump on the system and go look for that thing in there, that might be helpful. Now that's on our end, or Robert's end, would take some more work to get that built into the VAS view, but that might be helpful for the future. I don't know if anybody else thinks that or not. But
Are you
got
saying
some agreement.
as you describe things, go into the lab, look at them in the lab, and then
Yep.
go back to discussion?
yep,
So when you were going through like the air handlers and stuff like that, show people, have them click on that. That's probably a better idea.
Duly noted. Well, we will be back in lab next week, so that's one of the reasons I wanted to get a little bit of feedback here early. We'll ask for the feedback at the end of the training, of course, get some feedback, what was useful, what wasn't, that sort of thing. But I wanted to get a little bit of feedback before next week so that hopefully we can make it a better experience even next week. Speaking of next week, next slide, Ted. Homework. So next week, we are going to be talking about a thing called reset schedules. These are basically your automatically or self-adjusting set points. So I'd like you to go and see if you can find them or find a couple in your systems. Nothing that's associated with like an occupancy schedule or something, anything like that. Something that's more associated with the load in your building. Maybe it's tied to outside air temperature, maybe it's tied to something else. But that's the kind of thing that we're looking for. Also, go and find some trends within your building or your system. Think about how that data is useful to you specifically. Again, just like the alarms, you can trend data till the cows come home. There is so much building data out there, so much that's being logged in so many systems, but that doesn't mean all of that data is useful to us as technicians. Okay. So I want you to think when you look at those trends, what is useful to you and how do you make it useful? Do you look at it as a graph? Do you look at it as a chart? Do you export the data into some other tool and manipulate it from there? How does that work for you? And what would be a way to improve the quality of that data to make it more useful for you? Log it more often, less often. How does it work? That's what I want you to think of for next class. Make sense to everybody?
Robert, do we want to give them some potential ideas of where to look for those resets?
Great question, Ted. For those of you with hot water systems, boiler systems in particular, great place to look for them. Another place that we commonly see things like that are the air handlers.
And on the air handlers, look at your discharge errors. So
Yep.
maybe pressure resets. All right.
All right. Nobody has any further questions, concerns, contributions? We will see, or I will see everybody next week.
Hey, and Adam, see, you can use this from home if you want. Got a computer and internet connection at home. You can go on and try it at home instead of having to do it at work to get around the IT issue if you want. So,
Yep. And if you need a link resent, just shoot me an email.
yeah. Yeah, if you're working on it, you have questions too between now and then, just shoot Robert an email.
Yep. Don't shoot Ted an email. He won't answer this coming week.
Yeah, and I have not been on a system yet, so I would probably not be valuable anyway at this point.
All right. Have a great week, everybody. We will see you next week.
Yeah, have a great week.
Yeah, thanks everyone.